Hey everyone, in the following video I'm going to walk you through the steps to building this automated pet feeder powered by a Raspberry Pi. There are 4 different ways to trigger a feeding on this device, making it convenient to use whether you are at home or not. The first way to trigger a feeding is to simply press the button on the device itself. If you are not at home, the second way to trigger a feeding is to visit the website that is hosted on the Pi. The website also shows the full feeding history from all 4 trigger sources and is capable of showing live or motion captured videos should you also connect an optional Pi camera to the device. The third way to trigger a feeding is to schedule a one-time feed or a daily reoccurring feed. A one-time feed will run once at the specified time before being deleted. Reoccurring feeds will run at the same time every day until they are manually deleted. Both types of scheduled feeding are scheduled from the website hosted on the Pi. Finally, the fourth way to trigger a feeding is by calling the specified URL endpoint on the Pi. This endpoint can be triggered by a Google Home, Alexa, or virtually any internet-connected device that is capable of calling the URL.
Hey Google, feed the cat.
Feeding your cat now.
An optional enhancement to the feeder is the LCD screen on the top, which will display the last time a feeding occurred from any of the 4 trigger sources. This is not required for a fully operational feeder, but will also be included in this tutorial. Before we jump right in and start, I thought I would open up the device to give you a better understanding of the scope of this project. The first step will be to set up the Raspberry Pi. The Pi will host the website as well as the services needed to detect when the button is pressed. After the Pi is set up, the next step is to wire together the electrical components. Specifically, this entails the motor, the button, as well as the optional screen. Once the electrical components are completed and working correctly with the Pi, we will construct the enclosure as well as the ramp for the food to slide down. Finally, we will assemble everything into what you see right now. The device is designed in a way so that it can be easily disassembled and modified to make changes in the future. If building your own pet feeder like this interests you, then let's get started on the first step of the project, which is setting up the Raspberry Pi. We first must install the operating system onto a micro SD card, which will act as a hard drive for the Pi. This process is easiest done from another computer. I will be using Windows in this example, but a Mac or Linux works just as well. The other computer will need the ability to write to an SD card. If you don't have a computer that is capable of doing this, you can buy a thumb drive size device that plugs into your USB port and will write to an SD card for you. This is what I will be using, and I will link in the description below the exact one I used. I will also include an SD card recommendation. However, any SD card larger than 8 GB is sufficient, as well as a Class 10 speed rating or higher. The operating system we will be installing onto the Pi is called Raspbian, and it can be downloaded from the Pi website. To get to the website, we can simply Google Raspbian download, and it should be the first link from raspberrypi.org. We then want to download the Raspbian Stretch with desktop version, and we can download it as a zip. This file is about 1.3 gigabytes, so it will take a few minutes to download. After the OS is done downloading, we will need some software that is capable of writing this zipped up OS to the SD card. We will use the recommended SD card writing tool from Pi called Etcher. To get Etcher, we will click on the installation guide link. Here, you will also find directions if you are doing this setup on a Mac or Linux. We will then click on the Download Etcher button, which will redirect to the Etcher site. From there, I will click Download for Windows and let that finish downloading. The download is complete. Before we run the tool, we want to insert our SD card into the computer if you haven't done so yet. If you are prompted with any messages about formatting the drive, you can simply cancel these. We can now click on the Etcher executable and let that install. Once it is installed and running, you will notice that it recognized our SD card drive. If it does not do this for you, then change it to the correct location. We can now click the select image and select the downloaded OS zip file, which we first downloaded. Double check you are burning to the correct device and then click flash. This process will take about 5 to 10 minutes. Once the flashing is completed, we can close out the program and disconnect and remove the micro SD card from the machine itself. For now, this is all we need from the second computer. In the next step, we will connect the hardware components to the Pi so we can easily configure the software on it. To install the SD card into the Pi, simply slide it into the slot on the bottom with the SD card pins facing downward. Next, we will want to connect a USB keyboard and mouse. I am using a wireless keyboard and mouse, so I will just plug in the dongle to the USB port. You will also want to plug in a monitor via the HDMI port on the Pi itself. Once the Pi is set up, we will eventually be able to connect to the Pi without needing to connect a monitor, keyboard, and mouse, but for the initial setup, this is the easiest. After all these are connected, you want to plug in the power to the Pi itself. If you see the red light light up and raspberries load on your screen, everything is connected successfully. I will now switch over to the Pi itself to continue the installation. Okay, now that the Pi is loaded up, we will be greeted with this welcome wizard, and we'll just click on next. You'll want to choose your country, language, and time zone of origin. And then click next. You'll then want to enter a very secure password for the user called Pi on the machine. Then click next. You'll then want to find your local Wi-Fi network in the list and connect to that. Click next. And we will want to skip updating the software for now. We will do this at a later step. And simply click the reboot button and let the Pi reboot. Okay, after the machine has rebooted, we want to click on the Raspberry icon in the upper left-hand corner and go to Preferences, then click Raspberry Pi Configuration. On the System tab, you have some options. If you want to set the resolution, if it's not to your liking, you can do that there. And we then click on the Interfaces tab, and we'll want to enable VNC and Remote GPIO. We can also enable camera and SSH. If you want, we can get into more on that later, but it is optional. Click OK. And if you are prompted to reboot the machine after making any of these changes, you can do so now. Okay, the next step in the process is to update the system. We skipped this earlier on the welcome wizard because it occasionally crashes from that step, but we'll do it now from the terminal, which is more stable. To get to the terminal, you can simply click on this black square button on the taskbar or go to the Raspberry icon, Accessories, and click Terminal. From the terminal, we will type sudo apt-get update. And once that is complete, we will type sudo apt-get upgrade. And select Y to accept the downloads. Now this step might take a while depending on your home internet speed. And just a reminder that all these commands will be in the written directions document, which is linked below the video. And once this is complete, we'll want to reboot the machine by typing sudo reboot. After the Pi is done rebooting, the next step is optional, but it includes removing some unnecessary software that comes preloaded onto Raspbian OS. Again, this step is optional, but if you want to continue, we will need to just simply open up a terminal and type sudo apt-get purge LibreOffice with a star at the end. Click yes to continue with the removal, or type Y, sorry. Once that is complete, we can remove Minecraft Pi, which also comes preloaded and is not needed. Type Y and click enter. Once that is complete, we will want to run a few more commands to just clean up the system and purge any other files that are no longer needed. We will type sudo apt-get clean and sudo apt-get auto remove. Once this is complete, we will once again reboot the machine. And then we can continue on with the next step of installing all the necessary web feeder software that is needed for the feeder to work. So now that is complete, we will type in sudo reboot and move on to the next step of installing the web server software. Okay, in the next step, we will want to install some necessary software onto the Pi for the web feeder to work. So we'll want to open up a terminal. And the first bit of software that we'll need is to install Python and its development kit. Python is the software language that will be running the website itself. To install that, we will type in sudo apt-get install python-dev. Once that is complete, we will install Git, and Git will allow us to download the source code for the website itself. Once that is complete, we will install SQLite 3, which is the database platform we will use to store the feeding history. Once that is complete, we will install virtual env, and this allows us to separate our Python projects into separate virtual environments so we can have a separate entity. Once that is complete, we will install logrotate, and logrotate is helpful to manage the logs that come from the web server to make sure they don't completely fill up all the space on the micro SD card. Once that is complete, we will want to install Apache, and Apache is the web server software which will host our website. And the last three pieces of software are all related to Apache, and they're basically needed to help configure Apache correctly. Again, all these calls to install each one of pieces of these software is in the written directions below in the link, and it will walk you through step by step on how to install each one of these. And you can simply just copy them from the written directions and paste them into the terminal. And once the last bit of software is downloaded and installed, we can move on to the next step of configuring the website software itself. To set up the code for the feeder website, we will once again go back to the terminal. We can type clear to tidy up our workspace. And we will want to create a directory for the website to be hosted in. And after that is complete, we will change directory to that specific path. And we will create a virtual environment for Python called feeder in that directory. And this will go through and create an isolated environment for Python outside that of the Raspbian OS itself. Once that is complete, we can just tweak the permissions on the folder itself to make it a little bit more secure. After the permissions are completed, we can command down into the newly created virtual environment folder called feeder, and then we can activate the virtual environment by typing source space bin/activate. And you can see that the virtual environment is now active with it says feeder in front of the prompt. Now within the virtual environment itself, the website needs 2 additional Python packages. The first one being Flask, which is a micro framework that will host the website. So we can type pip install Flask to install that. Once that is complete, we can install a package called rpy.gpio, which is a Python package which will allow us to more easily communicate to the GPIO pins on the Raspberry Pi. We will eventually connect the motor and screen and buttons to those GPIO pins and use the code from the website to trigger those feedings. Once that is complete, we can actually go and use Git to clone and download the actual website software itself. That software is hosted on my GitLab repo, and you'll want to clone the latest version into the folder var/www/feeder. That will create another folder in the feeder folder called feeder, so we'll want to change directory into this new feeder folder. And from there we can run a quick Python script which will initialize the database and set up the app config for the website. So we'll type in python space create files.py, and you will notice that it created the database as well as the app config. Once this is complete, we'll have a few more new folders that we have since set up, so we'll once again want to rerun some of the permissions on these folders. And that concludes setting up the software needed to get the website running. For those who are more visually inclined, basically what we did there was we installed the website software under var www feeder, and here are the virtual files needed for Python, and clicking on that second feeder folder takes us to the website and all its software. In the next step, we will configure Apache to be able to access the website externally from the web. Before we start with the setup of the Apache configuration, we need a few more permissions to set up for Apache so it can talk to the GPIO pins properly without having to request permission every time. To do this, we will want to type in sudo by sudo. And under the section allow members of group sudo to execute any command, we want to type in the following. And you want to make certain that this is typed exactly as is with all the correct capitalization, as it will not work otherwise. And when that is complete, we can exit and save the file by typing Control X and then Y to save when, and then Enter to save when prompted. Once that is complete, we need to do 2 more commands to add some users to groups. And then we will finally be able to modify the Apache config so Apache is aware of our website. To do this, we will need to modify the default config file in Apache. So we will open up this file in nano and type in sudo nano and the directory path to the configuration itself. And once that file is open, you will see that Apache has placed in a default placeholder template for you to get an idea of how to set up this correctly. I already have the correct template that we will need in the written directions below. So you can just delete this whole example, copy and paste the one from the written directions, and paste it into this file. After you're done pasting the file, you can hit Control X to exit the file, select Y to modify, and enter to keep the file location. Okay, with Apache configured, we can now move on to the next step, which is setting up and installing the 2 background services that are needed for the website and feeder to work. The first one that we will set up is called the feeder button service. And this service is basically running in the background and constantly listening for the button on the device itself to be pressed. To set up this service, we will need to copy this shell command into the etc directory. Once that is done, we will change directory to that etc folder. Once inside that folder, we can modify the permissions of the file that we just copied over. And then we will update the defaults on the service. And then finally we can start the service. This service will run in the background, and it'll also start automatically anytime the machine is rebooted or stopped or start, so there's nothing really to worry about from that perspective. You can then clear the terminal and move on to installing the second service, which is the feeder time service. This service basically serves 2 functions. The first thing it does is update the screen on the device of the LCD, should you have one, every 5 minutes to check for the latest feed time. But more importantly, it also is constantly looking to see if there are any scheduled feeds that you have saved in the database, and will act on those feeds should the time for that time has passed. And basically the way to set up this feeder time service is same as the feeder button service. We just need to copy it over into the etc folder, change directory to that folder, set up some permissions on the service file, then update the defaults before finally starting this service as well. Again, all these commands are in the written directions, so you can just copy and paste them. As you see, I'm typing them out here and I have a few mistakes. They are correct in the written directions. And we will start the service as well before going ahead and rebooting the machine. Okay, after the Pi is done rebooting, the next step we want to do is configure log rotate. And like I mentioned before, log rotate will clean up the Apache logs to make sure they don't overflow all the space on our drive. So again, we'll want to open up a terminal window, and we'll want to open the log rotate config file for Apache by typing in sudo nano and go down to the Apache config file. From there, we want to keep the existing one. This is used by Apache itself. We want to append ours to it, and you can copy and paste the configuration from the written directions below. And you can just paste it below here. And then you can exit the file by hitting Control X, selecting Y to save, and then enter. This will basically keep 3 days worth of log files and rotate them on a daily basis. Now, to do a test to make sure that we set this up correctly, we can type in sudo log rotate -- force, pointing to the log rotate folder, and this will simulate log rotate running on a daily basis. And then to verify that this actually worked, we can actually go into our logs, which is under var www feeder under logs, and you'll see now that there's 2 Apache logs. When it gets to 3, it will cycle over and reset itself. You'll also notice that the feeder button service and the feeder time service did not have their logs recycled, and that's because those logs are handled within the services themselves running in the background. The next step will be to verify that we have set up everything correctly and to verify that the feeder site is running correctly locally. Okay, before we continue on, now's a good time to make sure that we have everything running locally correctly before we go on to the next step of configuring our router to make sure our website is available externally through the internet. To test that the website is working locally, we want to open up the web browser on the machine, either by clicking the globe in the taskbar or under the Raspberry icon. And to access the website locally, we can type in 127.0.0.1 into the navigation bar and hit enter. And if everything's set up correctly, the feeder website should load locally. And you will see one feed time already in there. That's by default to make sure that the site is working correctly. And if you click feed now, you will see that it says feed success and another entry is inserted into the list. Obviously no feeding took place as we haven't connected any components yet, but this is just a good test to ensure that the database is running correctly and everything has the correct permissions. In addition to this site, there is actually an admin panel that can also be accessed by typing in 127.0.0.1/admin. And the default login for this is admin, and the password is change me with an exclamation point at the end, and the C and the M are capital. So capital C, lowercase a, capital C, lowercase h, lowercase a, lowercase n, lowercase g, lowercase e, uppercase M, lowercase e, exclamation point. And from here you will notice that the time and button services are green and they're running correctly. And it is also a good idea to not use the default and to create your own with a secure password. You will also notice that there are a few other services there. The one is the SSH server, which can allow you to connect through the command line, as well as the webcam should we connect to Pi camera. We'll be covering those in future directions. But now that everything's working correctly locally, we can work on configuring our router to have this website working externally. To set up the router to accept web requests and serve up web pages from the Pi, we first must determine what the local IP address of the Pi is on your local network. From the terminal, we can simply type ifconfig . Under the WLAN 0 section on the second line, you will see an address that starts with 192.168. This is typically what the local IP addresses start with on a local network. You will want to make note of this. On the fourth line, also make note of the 12-digit address separated by colons. This is the MAC address of the wireless LAN. Make note of this as well, as it may be needed. Now that we have the local IP address of the Pi, as well as the MAC address, we need to log into our router and set up the router so our Pi always gets the same IP address. Each router is different, but we'll have a section called DHCP or reservations. As you can see on mine's under the network connectivity section, and then under the tab local network, you can see there's a button called DHCP reservations. And when I click on that, the DHCP reservation list is shown and typically consists of a table which you can add an entry in for the Pi with this local IP. You may also need to apply the MAC address. You may also need to be required to reboot the router after it's been saved. However, from now on, every time the Pi needs to obtain an IP address on your network, the router will always give it the same local IP. This will be helpful in the next step. The next step is also on your router, and it involves pointing external web traffic that comes into your local network to the Pi. This is called port forwarding. Web traffic comes in on port 80, so we will forward all traffic on this port to the Pi. Again, each router is different, but look for a section called single port forwarding. Mine is under the security section under apps and gaming. Create an entry for port 80 and forward it to the local IP address that we have written down earlier. Click OK or Apply and reboot the router as needed. To check if your router changes are working correctly, we need to try connecting from outside of your local network. The easiest way to do this without having to leave home is by trying to connect to the website using the data connection on your phone. However, now that you are no longer on your local network, connecting with the local IP address will no longer work. We need to connect with the single external IP address that your network provider gives you, which your router shares amongst all your local devices. The easiest way to determine your external IP address provided by your ISP is to go to Google and simply search, "What is my IP address?" You can now try typing this address into the browser on your phone and make sure you are able to connect to the Pi website. Now, unfortunately, your local network provider will not guarantee that this current external IP will always be the same. Plus, it is difficult to remember anyway. A free and more convenient way to solve this problem is to set up DuckDNS on the Pi. DuckDNS is a free service that will run on the Pi and associate your external IP with a memorable name. Therefore, anytime your ISP changes your external IP address, you will not be affected, as DuckDNS will update it from the service running on the Pi. There are numerous other services like DuckDNS. However, for simplicity, we will just cover this one in the tutorial. In the next step, we will go about setting up DuckDNS. Okay, before we can set up DuckDNS on the Pi, we first need to go to the DuckDNS website and set up an account. The website is duckdns.org, and when you get on the landing page, you'll need to sign in with one of the popular sites above. And after you do that, you will be on the main page of DuckDNS. And we'll have to pick a subdomain from duckdns.org. Choose something that will be memorable for you. And if it's available, it will appear down below. So the next thing to do is to click Install on the top nav bar, and this will generate the call and directions based upon which operating system. So we will be using Pi, and then down below we will choose our domain from the list. You can have up to 6 domains in your account for free. So if we go down below, here are the directions. I will walk through the directions, but you can also read them here in your own time. The important thing that we want is this call right here, which we will copy. Next, we will open up a terminal window. We will command down to our home directory. We will make a folder called DuckDNS. Command down into that folder. And create a shell file. So in the file, we want to copy the echo URL that we just copied from the website. We want to hit Control X to exit, Y to save, and Enter to keep the file name. Now back to the terminal, we need to set up some permissions. And then we need to set up the cron tab to run the cron job to run every 5 minutes to check if the IP address has changed to alert the DuckDNS website. To do that, we will type cron tab E. We will select 2 for nano to edit the file. Scroll to the bottom of the file. And we can copy this text from the website. If not, you can also copy this text from the directions in the comments below. Again, Control X, Y, Enter, Now that that is complete, we can try testing to make sure that DuckDNS is set up correctly. To do this, we go into the actual DuckDNS folder and run the shell that we just created. You see the call was successful, and if we look in the log that is created from the call, we will see that it returned back OK. If it was KO is returned, then there is an issue, so go back and re-look at these directions. Now every 5 minutes, DuckDNS will update your address for the subdomain that you chose. If you go back to the DuckDNS website now, you should see that your current IP is the current one that is externally provided for you by your ISP. This should correspond to the Google search of what's my IP that we previously did. You will no longer need to know now when or if your IP address changes. You can now externally visit the feeder site through the full link of this.duckdns.org. In the next step of directions, we will go through about how to connect to the Pi remotely without needing to use a monitor or physical mouse or keyboard. We will do this using VNC. Now that the Pi is set up, before we go on to the next step of the build process, it is good to cover how to connect to the Pi without having to connect a keyboard, mouse, and monitor every time. This will be helpful should we ever need to change something on the Pi once it is inside the feeder. We will be able to connect remotely to the Pi using VNC. We previously enabled VNC in the settings on the Pi. If you did not do this, go back and do it now. I am now back on my secondary Windows machine, and to connect to the Pi from this computer, we first must download VNC Viewer. To get VNC Viewer, we can go to Google and type VNC Viewer, and click on the realvnc.com link, which should be the first one. You'll see VNC Viewer is available for a variety of different platforms. I already downloaded it for Windows, but you can download it for the operating system of your choice. Click download and install. Once VNC Viewer is downloaded and installed, we can launch it. And in the search address bar, type in the local IP address that we previously noted. If it's your first time connecting, you might be prompted with a catchphrase dialog box. Just simply accept that, and then you will be prompted with an authentication window, and for here we will provide the credentials to log into the Pi. And it's really that simple. We can now connect to the Pi and control it remotely, and we can do this from any machine that we have VNC Viewer on. This concludes the section of setting up the Raspberry Pi. However, there are still a few more helpful tips about the Pi setup we should touch on before moving on to the next section in the build process. As I alluded to earlier, when a Pi camera is attached to the Pi, the website is capable of streaming live video as well as capturing motion-triggered videos for you to view anytime from the website. Since this is an optional feature, I have decided not to include the setup process for this in the main Pi setup section. However, I will include the full directions to set the camera and software up at the end of this video. I will also include a link to the exact time mark in the description below. The second point worth mentioning is about the correct way to shut down the Pi. Whenever you are working with the Pi, make sure you shut it down properly by going to the Raspberry icon and selecting Shut Down, or running sudo shutdown from the terminal. The SD card can become easily corrupted and ruined should you just unplug the power plug directly from the Pi. Thirdly, in the last step we covered how to remotely connect to the Pi using VNC. VNC allows us to control the GUI on the Pi remotely from another computer. Another way to control the Pi remotely is through SSH, which is a non-GUI terminal-based way to connect and issue commands. SSH can be turned on via the Interfaces tab as we discussed earlier. There are loads of other videos online about setting up and using SSH. Finally, as I have mentioned several times throughout the video, please consult the written directions linked in the comments. The video and the written directions are meant to be used together to help you complete this project successfully. What's more, in the next sections where we begin physically building the device, the written directions will come in even greater use, as they will contain exact measurements as well as templates that can be used for construction. The next step will be to configure the electrical components needed on the feeder device. We will not need the Pi again until the electrical components are complete, at which point we will use the Pi to test that the electrical components are working as expected. Therefore, you can leave the Pi running in the meantime, otherwise please shut it down correctly and put it aside. And with that, let's get started on the next section of setting up the electrical components. Okay, the first electrical component that we'll want to set up is the button that will go on the feeder box itself. And the first step we want to do is cut two pieces of wire that are 24 inches long. This doesn't need to be super precise. Just take one, cut it 24 inches, and cut another one roughly the same size. And after that's done, we're going to want to take one female to female breadboard wire, fold it in half, and then go ahead and cut that in half as well. After we cut that in half, we're going to want to remove about a ½ inch from both ends of the 24-inch wires. Again, this is probably a little bit more than we'll need, but we can take some of it off later. But this is just a good amount to start with. And once those four ends are removed, we're going to want to take the ends off each of the breadboard wires as well. About a ½ inch is fine. And once that's done, we're going to want to take each of the breadboard wires and twist them to one end of each of the two 24-inch wires. In my case, my 24-inch wire is a little bit thicker than the breadboard wire, so it kind of helps to manually twist it together into a braid to help the connection be a little bit more secure. And this doesn't need to be super tight, it just needs to be held in place for now, where in the next step we're going to solder this connection together and make it much more secure. So you just want to kind of twist them together so they hold in place by themselves. And we want to do that for the second wire as well. Now that those are both twisted in place, we can move on to the next step, which is soldering both of these connections so they are more secure. So just give me 1 second and let me take out my soldering machine. Okay, now that I have my soldering tool out, you'll want to plug it in and turn it on. I find turning it on to the max setting is helpful for this particular iron that I have. You also want to make sure that you're in a well ventilated area so you don't inhale any of the fumes from the solder itself. And I also find using one of these helping hands is helpful to keep the wires in place while I solder the connection down. I'll include a link in the description to the one I'm using right now. And there are loads of videos online about how to solder correctly. I'm by no means an expert on the subject, but there are lots more people there are. But basically, you want to make sure that the iron is touching the wire to make sure that the wire is hot enough for the solder to flow onto the wire. You don't want to just touch the iron to the wire and then with the hot iron touch the solder to the wire. It's called a cold joint and it's not the best joint for what we want to do. So we want to make sure that the iron is nice and hot, it gets the wire nice and hot, and then the solder flows onto the wire naturally from the heat of the iron and not just by the iron touching the solder itself. I find it helpful to stick the iron on the bottom side of the wire and it lets it heat up and then hold down the solder on the top until it gets hot enough and it'll naturally wick onto the wire. And these wires are pretty small, so it should heat up fairly quickly, but you just want to be a little patient depending on how hot your iron is. It may take a minute or two for the wire to heat up. And once that is done, we can stick our helping hand aside. And we want to secure the connection on both of these joints. You can use electrical tape. I prefer using the heat shrink tubing. Again, I'll put a description in the link below to the kind I recommend, but it's easy enough to use. It comes in various different sizes. You can just cut them down to the length of your joint, then put it on the other side of the wire, and then with a heat source such as a lighter or a match, run it over the tubing and it'll shrink over the connection, keeping it more secure and in place. And once both of these connections have shrink wrap tubing placed around them, the next step we want to do is to take the exposed ends of the 24-inch wire and we're going to want to solder them to the button themselves, the button itself. And to add some stability and to make soldering both of these ends to the button easier, we will be using a PCB board, and the link to that is in the description as well below. These boards typically are bigger than the size that we need, so the next step we will do is to cut the board down into a more manageable size before soldering on the 24-inch ends. Okay, these PCB boards are typically 1.5 inches wide, and for our use we'll want a board that's 1.5 inches by 1.25 inches. So we can keep the width of the board at 1.5, and we can cut the other side down to be 1.25 length. These boards are fairly heavy duty, so you'll want to use a good strong pair of scissors to cut these. I have these heavy duty ones here. And just keep note of which line of holes to cut along. Cut it in half. So now we're stuck with a PCB board that's 1.5 by 1.25 inch. And now that we have that, we want to stick the button as best as possible onto the center of the PCB board. The button itself has 4 prongs that stick out the bottom. 2 of the prongs are closer on one side and 2 are closer on the other. I typically refer to those as the sides. So for this instance, we'd want to solder both of the 24-inch wires to one side of the button. It doesn't matter which one it is, but we just want to solder it on the one side where 2 of the buttons are closer together. In the written documentation, I have close-up pictures that help better illustrate this. There's an image link next to each step that I'm going through. You can just click on that image link and you can get a closer idea to understand what I'm talking about. But basically, just take the 2 shorter side and we'll want to solder each wire onto that. So we'll want to turn our soldering iron back on and let that heat up, and once again make sure you're in a well ventilated area. And we'll want to take the first wire and try and wrap it around as best you can to the prong that's sticking out of the bottom. The goal here is really just like the first time, just to kind of have it sit in place long enough for us to solder it in place. And like I mentioned previously, you want the solder to be drawn to the wire once it's hot enough. And once that's done, we'll want to move on and connect the other wire to the other end of the shorter post on the button itself. If the 1/2-inch wire that we stripped is too long, you can just twist it and cut off a little bit at this point. And the one thing you want to keep in mind is to make sure that the soldered connections are not touching each other and are not connected through the holes on the PCB board itself. You want to make sure that there are 2 separate connections that aren't connected by solder in any way possible. And as I mentioned previously, you want to have the wire get nice and hot. And in this instance, it's taking a little bit longer than normal, but if you just stick with it and be a little bit patient, eventually it will get hot enough to draw the solder down to the connection itself. And we can't use heat shrink tubing on this instance, but later on, once we verify that these connections are working, we will wrap the PCB board in some electrical tape to give it some stability, to make it a little bit stronger once we stick it inside the box itself. But we will do that after we test it that this is working correctly with the Pi. So as you can see, both of these are soldered on securely. So we'll move on to the next step of soldering together the motor and the relay. Okay, the next step we want to do is to solder some wire to both connections, the positive and negative connections on the motor, sorry. There are 2 little posts on the back end of the motor. If you look closely enough, one's marked positive and one is marked negative. And basically we want to take 2 8-inch pieces of wire, strip about a 1/4 inch off each one, and solder them onto the posts on the motor themselves. So the first thing we want to do is to measure out 8 inches of wire and cut that. And then take another 8-inch length of wire and cut another piece off. Now that we have those cut, we want to strip the wire on all 4 ends of these pieces. We don't need to do a 1/2 inch like before, we can do about a 1/4 inch this time. And once that is done, we're going to want to wrap each wire around both posts on the back of the motor. And the posts have little holes on them, so it is kind of helpful to twist the wire and braid it and kind of slide it through the hole in the post. That's what I'm doing now, kind of off camera a little bit. And basically the goal there is just to help keep the wire in place so it doesn't move around as we solder it down. And once that is done, we can do the same thing for the second wire and attach it to the post. And once that is done, we'll want to turn on our soldering gun iron and make sure that that gets up the temperature, and then solder the post to the wire itself. Again, like with the button, we'll eventually wrap this in electrical tape just for some security, so it stays in place inside the box. But for now, we will leave it like this and just make sure that all the components are working before we wrap everything up. So now that the first post is done, I can just move the wire out of the way and move on to the second post. And once this post is soldered down, the next step we will want to do is to set up the relay, and we'll connect the relay and the power button for the motor itself. So we'll go ahead and continue with that in the next step. Okay, now that we have our motor wired up, we'll want to connect both of these wires to the relay and power plug that will help power the motor itself. The motor will be powered externally. It is not strong, the Pi is not strong enough to power the motor, so we'll help use this relay, which the Pi will tell the motor when to turn on and off to trigger the feeding. And the first thing we'll want to do is to insert the negative wire of the motor to the first hole of the K1 section on the relay. The K1 section is on the right hand side, and we do not want any of the negative motor wire exposed from the first section of the relay, so you'll need to trim that if needed to make sure no wire is exposed. And once it's fitting inside slot 1, then we'll want to screw it down. And once that's screwed down, we'll want to cut another 8-inch piece of wire and strip both ends about 1/4 of an inch again. And once that is complete, we'll want to take one side of this newly cut 8-inch wire and insert it into the second hole on the K1 section of the relay and screw it down. These screws are pretty tiny, so you'll need a tiny T0 Phillips bit. I'll put a link in the description to the set that I have. It also includes various sizes, which can come in handy in this project and future projects. So here I'm sticking the 8-inch wire into the second hole and screwing it down to make sure that it is secure. And again, you don't want any of the wire showing, so if you screw it down and you see some of the wire exposed, take it back out and trim it down. So then we'll take the other end of this 8-inch piece and insert it into the negative terminal on the of the female power plug. Again, if it's too much wire, just trim it down a bit so no wire is showing, and tighten down the screw so it's snug and the wire doesn't come loose. Next step is we want to take the positive wire of the motor and connect it to the positive terminal of the female power plug. Again, just trim the wire as necessary so nothing is showing. And once it's securely in place, just screw it down. And again, the setup is in the written directions. If you didn't follow that 100%, you can go back and rewatch that. But the next step we would want to do is to take 3 female breadboard wires, and on the opposite side of the relay, take each one of the negative female to female breadboard wires, and we want to plug them into the ground spot, the VCC spot, and the spot that's marked IN1. And we want to plug these in to the section directly diagonally from the K1 slots. And once this is complete, we can take this along with the button and plug them into the Pi to test to make sure that we have everything wired and working correctly. Okay, now that we have our button, motor, relay, and female power plug set up, we'll just want to do a quick test before moving on to make sure that we have all these set up and working correctly with the Pi. So we'll want to plug our Pi back in and make sure that is working and all the services are running correctly. If you have not set those up correctly in the first section of this video, go back to that and make sure your Pi is set up correctly. Then the next thing we'll want to do is to plug in the connections. There are 5 connections that we want to plug in, 2 from the button and then 3 from the relay to the actual GPIO pins on the Pi. There are 40 GPIO pins on the Pi. Number 1 and 2 start on the opposite ends of the USB section of the Pi and go all the way up to 39 and 40, which are the closer ends to the USB ports. So for the buttons, we'll want to plug in the first wire to spot 9, and the second wire we'll have to plug into spot 12. It doesn't matter which wire goes into which for the button, so you'll just want to start at step 1 and plug it into 9 and 12. And at this point I'll bring up a picture of the GPIO pins on the Pi so you get a better idea of which is the even and which is the odd. And once we have those plugged in, we'll want to plug in the 3 wires from the relay into the Pi itself. The VCC wire we'll want to plug into GPIO pin 4. The ground we'll want to plug into pin 14. And the IN1 wire we'll want to plug into pin 11. And those should slide in fairly easily with no trouble. And once we have all 5 of those set up, we'll want to test by clicking the button, and you should see the relay light up with the button in the corner, but you'll notice that the motor doesn't do anything. That's because the motor is driven by this power plug here. So we'll need to take and power the motor with another plug, which I will plug in now. So once I have that plugged in, the relay will be sending a signal to turn the motor on, and the motor will actually have power now. So if we go ahead and hit the button now, you'll see the relay red light turn on and the motor spin. Not sure how well you could see that, so I'll do it again. And if you hit the button, you'll see that the motor turns counterclockwise. If your motor turns clockwise, then you wired the wires backwards on the motor, and you'll just want to go ahead and swap those around on the power port themselves. It's not detrimental to the pie, or sorry, to the feeder. The food will just come out closer to the right hand side of the box. But as I just mentioned, if you want to reverse the direction of the motor, just take the 2 wires on the female power plug and reverse them. And once we have verified that all those are working correctly, we can go ahead and secure some of these connections with electrical tape. So once they get inside the box, or if the boxes move around or falls, that we can ensure that the connections stay secure. And one optional thing before we move on with securing with electrical tape is it's a good idea to label each one of these connections to the terminating spot that they go in, just so in the future, in case one of them does come out, it becomes clear where it is that it needs to go back into. So for instance, for the motor, I just take a piece of paper with clear tape and I mark that this section needs to go into, for instance, slot 1 of the relay, or that this wire needs to go into the positive power port of the female plug. Or for instance, for the buttons, I mark each one with 9 and 12 of the GPIO pin, just as a reminder that these wires go into GPIO pin 9 or 12, or for the relays they go into pins 4, 14, or 11. And again, this is optional. It just kind of helps moving forward, especially if you do decide to go in the next section to set up the LCD screen. There are a lot of wires that come along with setting up the LCD screen correctly. So there can be quite a bit of wires in the box. So it kind of helps to keep track of where everything goes. And one thing to keep in mind, especially for the wires going into the Pi, is you want to keep the little taped notes away from the terminating end. Otherwise, you'll just have a bunch of paper sticking really close to the Pi once we get to final assembly. So, and again, that is optional. If you do, you can do that in your own time, but now we'll move on to the next step, which is highly recommended, which is securing these soldered connections with electrical tape. And the first one we'll do will be the button, and there's really no right way to tape these down. We're just adding some stability to the button itself. Eventually this button will be screwed onto the top of the box, so you don't have to worry about putting too much tape everywhere. Eventually we will have to drill some holes into that in the future directions. But for the first piece of tape, you want to keep in mind that the wires will go away from the front of the box. So in this instance, I'm just putting an initial piece of tape down to make sure that they go directly in that direction before wrapping up the sides to secure the actual button itself. And again, you can put as much tape as you want on the PCB board itself. It's not going to hurt anything. It just will help keep those connections and joints in place to make sure that they're secure once they're in the box. And again, in the written directions, I have some close-up pictures to get a better idea of how much electrical tape I put down in this instance. But once you're happy with that, can move on to the next step, which will be wiring up or taping down the points on the end of the motor. And here's the final product once I'm done wrapping up the button. And for the motor, just want to keep in mind that the wires tend to come out vertically from the posts themselves. So the first few pieces of the motor itself is handy to make sure that the wires don't get overextended. And then once you have those pieces in place, there's a thinner section on the back that you can just wrap around electrical tape to secure those initial pieces in place. Again, I have some close-ups of the written directions of what I'm talking about. I know some of this is off camera now, so it's slightly confusing, but like I said before, there's no right or wrong way to do this. We're just taping down the points so they're a little bit more secure. And you can be as generous with the electrical tape as you want. We've already tested these connections, and at this point we're sure they're working. So at this point, we shouldn't ever need to take off this electrical tape again, now that we know everything's working from a setup perspective. And as I mentioned before, I have a few pieces of tape just to keep the wires down. And then once I have those wires down, I'll just wrap up around the outside with some tape to make sure that those initial pieces of tape are secured in place. And once you're happy with that, we can move on to the next step. And the next step is wiring together and soldering all the connections for the LCD screen. As I alluded to earlier, the LCD screen is not required for the box to work completely, but it is a nice little feature. Okay, the first step to set up the LCD screen that we want to do is to cut 11 24-inch wires. So in this walkthrough, I will just do one of the 11, and then at the end you can go ahead and do that 10 more times. So the first step that we want to do is to cut a piece of wire 24 inches long, and then we want to take about a ½ inch off both ends of the wire. And then once that's done, we want to take one female to female breadboard wire and go ahead and cut that in half. And then strip about a ½ inch off the ends of both sides of these as well. And then we want to go ahead and twist both of these onto both sides of the 24-inch wire. And for right here, you basically just want to twist them together tight enough so that they're held in place before we solder them together, kind of like we did with the button wires. So here I'm just twisting them in place for them to be held up tight enough before we solder them together. So now that that's done, we can go ahead and take out our soldering tools and make sure we're in a well ventilated area. And we want to solder the two connections. Then go ahead and just solder the other side as well. Once both of those connections are done, we want to go ahead and remove one of the black tips from one side of the wire. The easiest way I found to do this is just to take one of the male pins from the breadboard wires and kind of stick it under the black clip on the top, holding it in place. And once that black strip is up in the air, you can just go ahead and the top slides right off. And the little plastic piece on top that is clipped in, you can see that's kind of sticking up now. It allows it to slide right off. You can put it back on in the future just by pushing that little plastic piece back down. But for this step, we want to leave the one side off. And now that we have the one side off, we can go ahead and shore up both of those solder connections with some heat shrink tubing. Like I mentioned before, we'll have to go ahead and repeat this process 10 more times, so we'll have 11 24-inch wires, and the process will repeat it the same way. So at the end, you'll have 11 24-inch wires. One side will have the plastic cap removed, and the other end will keep it. Eventually, what we'll end up doing is soldering the connection with the plastic cap removed onto the LCD screen, and then the side with the black cap still in place will be connected to the Pi. And as I mentioned before, I'll just do one wire, and then you can go ahead and repeat that step 10 more times to create 11 wires. So here I'm just finishing up the first wire and heating up the heat shrink tubing, so we have one exposed end and one non-exposed end. And then off camera, I'll go ahead and do that 10 more times for a total of 11 of these wires. So you can go ahead and do that now. And once you're completed with that, we can go ahead and move on to the next step. Okay, now that those 11 wires are done, we're going to have to do a slightly similar step now, but we'll start off by cutting 3 30-inch long wires. And again, I will just do one on recording, then you can proceed to do the other two yourself. So the first thing that we'll want to do is to cut a 30-inch length of wire and strip both ends just as before. And once that's done, we'll once again take one female to female breadboard wire and cut it in half. And once it's cut in half, we'll only need one side of it for right now, and we'll strip the end of it about a 1/2 inch and attach it to one side of the 30-inch wire. And again, we just want this secure enough to be held in place before we actually solder this connection. So once that's twisted together, we can take our soldering tools back out and our third arm and clamp it down before soldering it down. And the purpose of these three 30-inch wires will be that they will connect to the potentiometer, and the potentiometer is what will adjust the contrast of the screen, which you will see in future steps. But since to fit in the box, it's best that the potentiometer is off to the side. That's why we're making those wires a little bit longer. So now that that solder is done, we can go ahead and slip on a heat shrink tubing onto the open end of the 30-inch wire and heat that up so it fits over the connection. And once that is complete, we're going to want to do that 2 more times for a total of 3 wires, which are 30 inches long and which have one exposed side of wire and then one female side soldered on. Now the only slight caveat is for the last wire, we want to go ahead and remove the black tip by removing off the tab. So we have now 2 wires 30 inches long with the black connectors on, and then once with one removed at the end but still exposed on the other side. Now that we have these 3 wires set up, we're going to want to solder them onto the potentiometer using the 3 exposed sides of each of the 3 wires. You can solder them directly to the potentiometer, but in this example, we will connect it to the breadboard. In the written directions, I've soldered it directly to the potentiometer. If you want to get an idea of what that looks like, you can look at the pictures in the written directions. But basically, we want to take each wire and we want to connect it to one of the 3 pins on the potentiometer. The potentiometer is labeled 1 through 3. If you look on the top, you'll see one on the left-hand side labeled 1 and the one on the right-hand side with 3. The one that's labeled 3, we're going to solder on the third wire with the black plastic cap removed. And as I mentioned, in this example, I'm going to try soldering the 3 of these on using the breadboard. And before I start with the soldering, I just put some clear plastic tape onto the top of the potentiometer just to kind of keep it in place. One less thing I have to worry about moving around when I make the solder connection. You'll need some patience for this step. Getting the wires onto the potentiometer and getting them in place well enough for you to solder will require some patience, mostly because you're working with a small, close area. And in addition, the potentiometer wires are pretty flimsy, so you want to be careful with them to make sure that you don't bend them to the point where they're not really usable anymore. So you definitely want to be careful while you're doing this. As you see, it takes me a couple times and patience to actually reset and kind of twist the wires so they're together enough to be able to wrap around the first post of the potentiometer. But just take some patience and you'll figure it out. It helps to jam it into the hole that the potentiometer post is coming out of to kind of give it stability, and then wrap it around the actual post itself before soldering the connection down. And similarly, like we discussed, when using the button and the breadboard, you don't want the connections to cross over on the breadboard pins themselves. So make sure while you're doing each three of these solder connections that they're not crossed over in any possible way. So you'll see here, after playing around with it, I'm finally able to get the first post down to where I like it, and once it's in a position that you like, you can go ahead and solder it down before moving on to the second post. And once that post is soldered down, we can move on to connecting the second wire to the second post on the potentiometer. Now, one thing I did forget to do here was to put on some heat shrink tubing onto the wire before I did the solder connection. So like I mentioned before, the black plastic caps are removable. So I'll just go ahead and take it off for a second to slide on the heat shrink tubing. And then once the tubing is on, I can push the black tab on the cap back, and it'll slide right back onto the end of the wire. So now that I've removed it, I'll take a piece of tubing and I'll cut the tubing in half. The tubing's a little bit long. It goes a little bit further if you cut it in half. And then I'll slide it down the wire and heat it up around the connection. Don't necessarily need a helping hand for this instance. It's just helping me keep it steady while I'm recording. So once the tubing is tight against the post and the soldered connection, we can go ahead with the second wire. But first we want to make sure we put the tab back on, and like I said, pushing down the tab and then sliding it back on upright, it clicks right on and you're good to go. And before we start the second one, we want to go ahead and remember to insert our heat shrink tubing onto the second one. And it's basically a similar process, so I'll kind of go quickly through this. You can see this time, after much fiddling off camera, making sure that I have it correctly, I'll go ahead and solder the second post down. And take your time with this. Like I said, you're not going to get it on the first try. So just be careful, and then once you have it the way you like it and making sure the wires aren't crossed, you can go ahead and solder it down. And once the second post is soldered down, make sure it's not cross-threading with any of the holes on the breadboard with the first post. And once you're satisfied, you can go ahead and heat up the shrink tubing around the second connection. Before moving on to the third connection wire, which we removed the black post on the other side with. And it's right around after this point that I realized that my camera ran out of batteries and was not recording, so I don't have filmed adding the third wire, but it is exactly like the first two. And this is the final result with all three heat shrink tubed on. And I went ahead and trimmed down the breadboard as well with my heavy duty scissors. And just to recap, the first two posts on the potentiometer have the black tab still kept in place, and the third one has it removed. Okay, now that we have the wires set up as well as our potentiometer, we can go ahead and start soldering these wires onto the LCD itself. And the LCD has 16 pins. You'll notice they're labeled 1 through 16 on the back. And for our purposes, we're going to be using pins 1 through 6 as well as pins 11 through 16. And we'll start on post number 1, and we'll take one of the 24-inch wires and we'll plug in the side that we removed the black tab on. And we will solder that connection down using our smallest tip for the soldering gun. And calling it soldering is not super accurate. Basically, we want to just get some solder into the connection between the post and the actual wire just to hold it in place. We're kind of doing a cold soldering joint here, and we just kind of want to use the solder almost as glue to hold it in place. So as you'll see, I took a piece of heat shrink tubing before sliding on the first 24-inch wire onto the first spot of the LCD. And we will also take a 24-inch wire to the second post. And for the third post, we're going to be taking the third exposed wire from the potentiometer and plugging that into post 3. So we'll do 1 and 2 with the 24-inch wire, and then the third wire we'll go ahead and connect via the potentiometer. The last two on the potentiometer will go onto the Pi itself. So we'll just unplug the third post here and start with the first post. And to give you a better idea, I will change the camera angle to give you a close-up of what I mean by just quickly soldering this post down. You want to be very careful when soldering these wires to the LCD. If it gets too hot, you will melt the pin right off the LCD screen. So as you'll see here, I just quickly touch some solder and you could see it flow into the wire and the pin just quickly connect in it. And that's all you need. If you leave it on much longer, you risk melting the pin right off the LCD board itself. So just a quick tap just to get some solder in between the gap on that wire and onto the post, just enough to hold it in place, is all you really need. And once that is done, you can go ahead and move the heat shrink tubing back over to the post and connection. And put a flame to that to have it shrink into place. And for the second post, we're going to want to go ahead and use another 24-inch wire and do a similar process. Again, you'll notice that I have it in place. I just quickly apply some solder and heat to the joint inside, just enough so it melts into place and holds it. And that's really all you need before applying the heat shrink tubing. Again, as I mentioned previously, the third post will be from the exposed third post from the potentiometer will connect to the third post on the LCD screen. So you'll do that next, and after that, pins 4, 5, 6, 11, 12, 13, 14, 15, and 16, those will be used with the rest of the 24-inch wires that we used previously. And that will use up all the extra wires at this point. You won't have any more 24-inch wires. They'll all be connected to the LCD. And here I am connecting the third one, which is coming from the potentiometer, and it's just exactly like the first two. So I'll go ahead and skip doing the rest and show you the final product, which, as you can see, is done. As I mentioned before, we used posts 1, 2, 3, 4, 5, 6, skip 7, 8, 9, 10, and 11, 12, 13, 14, 15, and 16 are used. We'll be using all the 24-inch wires, as we said, and the third post connects to the third post on the potentiometer. So now we have two black tabs coming from the potentiometer and the rest coming from the LCD. Those will all be plugged into the Pi, which we will now test. So once again, before moving on to the next step, we can test to make sure that our LCD is working with our button, motor, relay, and power plug. We already tested all the other components previously, so we can plug those in as we did before when we were testing, but this time we will also be plugging in the LCD screen and the potentiometer. And just to recap, button 1 will go into pin 9 on the GPIO, button 2 will go into pin 12 on the relay, the VCC pin will go to GPIO pin 4, the relay pin ground will go to pin 14, and relay pin IN1 will go to GPIO pin 11. And then on the potentiometer, pin 1 will go to GPIO 1, pin 2 will go to GPIO pin 39, and the third pin on the potentiometer, as we discussed before, will go to the LCD pin 3. And then I'll quickly go over each slot for the LCD pin. This will be in the written directions, so consult those. I'll just quickly go over them now. But LCD pin 1 will go to GPIO pin 6. LCD pin 2 goes to GPIO pin 2. LCD pin 3 will go to potentiometer pin 3. LCD pin 4 to GPIO pin 37. LCD pin 5 will go to GPIO pin 34. LCD pin 6 to GPIO pin 35. LCD 11 to GPIO 33, LCD 12 to GPIO pin 31, LCD 13 to GPIO pin 29, LCD 14 to GPIO 23, LCD 15 to pin 17, and LCD pin 16 to GPIO pin 25. Again, reference the written directions for these. But after all those are plugged in, we want to go ahead and turn on the Pi, like with our initial testing, to make sure this is working. And if the screen turns on, that's a good sign. And as the Pi boots, it'll show the last feed time. And if the screen's a little dark or dim or it's hard to read, then you can adjust the potentiometer to get the contrast that you see fit. And as you can see, our screen is showing, which that is a good sign, so we have everything connected correctly. And now we can test the potentiometer to make sure it's working. So just giving it a quick test, just turn it one way or the other, you'll start to see that the contrast changes. It doesn't show up very well on the camera, but it will in person. So as you can see, it did change a little bit, so we can verify that that is working. So now we want to try hitting the button and to see if the screen is updated after a feed occurs. So we press the button, you'll see the relay light turn on and the motor spin, and then we see the feed time updated. So that's great. So now we know everything is working from an electrical perspective. And with that, that's the last electrical component that we need for now before we can move on to the next step of building the actual component box. You can go ahead and shut down the Pi and put this aside for now. One other helpful note, like we did with the buttons before, is we want to go ahead and label all these wires. There are quite a few now. And we can also wrap some electrical tape around the potentiometer just to make it a little bit more sturdy, to make sure the wires aren't damaged once they go into the box or moved in transit or whatnot. So I will go ahead and do that in the next step. Okay, so you can see I went ahead and I labeled each wire coming out of the LCD, and I put the appropriate GPIO pin number onto the wire itself. I did it right after the soldered connection from the breadboard wire, so it doesn't stay too close to the actual Raspberry Pi itself once they're all plugged in. I also then went ahead and put a bunch of electrical tape around the potentiometer just to give it some more stability and to keep the wires more in place. And basically you can wrap as much electrical tape around it as you want. You just want to make sure that the part that spins is free. So you'll see what I did. I just went ahead and wrapped a bunch of electrical tape around that and set the numbers on each one. So now that's complete, we can move on to the next section, which is to set up the actual box and wooden components itself. Okay, the first step to building the box will be to measure out the pieces that are needed to construct the box itself. And we're going to have a top and bottom piece, a front and back, and a left and right side. The top piece will be 11.5 by 7 inches. The front will be and back will be 9 by 7 inches. And the left side and right side will be 11 inches by 9 inches. If you look in the middle, you'll see 8 little tabs. Those will be a 1/2 inch by 3/8 of an inch, and we'll get into more details about what they do later in the build. And the last piece is the bottom piece, which doesn't fit on this 2 foot by 2 foot board. So I have a second board, and I traced out the bottom piece, which is 11 by 6.5 inches. We'll use the rest of the second board later to construct the ramp. And this is the type of boarding that I use. It's just MDF material, 2 foot by 2 foot. You can find it at your local Orange hardware store. They have a 2 foot by 4 foot piece, but it's a little bit more wieldy to carry back home, and it's also a little bit more expensive. So you're better off just getting 2 of the 2 foot by 2 foot pieces. And the measurements, like I said, are in the written directions, and this is what you'll end up with. So you can pause this and take a look at this. I won't go through and show myself tracing all these out on the board, but you want to make sure that you take your time and that you have all the measurements done correctly, and make sure that they are all lined up before moving on to the next step. And the next step will be to cut out all these pieces from the MDF board itself. You can go ahead and get a different kind of board if you don't want to use MDF. If you want to use real wood, you can certainly do that as well. But just keep in mind that all these measurements are designed off the fact that the board is 1/4 inches thick. If you go ahead to your local hardware store and decide on a different type of wood or boarding, just make sure it's 1/4 inches thick. If not, then make sure you adjust all the calculations accordingly. So here I'm just going through and cutting out all the pieces that we went ahead and laid out on the board. You want to make sure that you're wearing gloves as well as eye protection and something over your mouth as well, so you don't inhale any of the dust particles from the wood. And I have a jigsaw, so I'm go ahead and making my cuts using that, but you can use a regular handsaw or any other type of saw that you feel most comfortable with making the straightest cuts possible. So take your time and go through and cut through each of the boards. And once your cuts are complete, it doesn't hurt to run some 100 grit sandpaper around the edges just to smooth them off a little bit, as well as the 8 pieces smaller tabs that we have. Want to run through those and make sure that they're flat on at least one side of the longer side, because we are going to go ahead and glue those onto the side of the board. As I said, we'll cover those later. And you'll see after those are all done and cut, we have all our pieces cut out, so we can move on to the next step. Okay, the next step is to cut out the template for the top piece. So we'll go ahead and start by cutting the 2 solid side lines on each side of the paper. And the dotted line in the middle is just meant to separate both pieces. So the next step will be to cut the 2 solid lines on either side of the dotted line, and this will create the template for the top piece. The rectangular section will be for the LCD screen, so don't cut that out if you're not including it, and then the circle will be the button. And the 2 semicircles will be where the top of the feeder protrudes from the top of the box. So go ahead and cut out both of the top pieces. And then this template itself is not as long as the top of the box, so we want to center it up on the bottom of the top piece. And once we make sure that everything looks correctly, then we can go ahead and cut out the LCD section, if you choose to include that, as well as the button circle. And after both of those are cut out, we will go ahead and line up both templates on the bottom, starting at the bottom of the top piece, and we'll tape it down, and we will go ahead and trace all the pieces that we will need to make our cuts on. So we will trace around the center of the 2 semicircles, around the button itself, around the LCD screen, and then we will draw a line down the middle between the 2 templates. Now the templates aren't perfectly half and half on top of the box. The LCD side is a little bit longer than the button side, so you don't want to just take half of the box and draw it right down the middle. You want to draw a line down where the middle of where the 2 templates start. So like I said, we'll go ahead and once we're sure that they're lined up correctly, we'll go ahead and tape it starting from the bottom of the top piece of the box, and we'll just tape it down in a few spots so when we're doing our trace, the templates don't move. And then we can go ahead and with a pen or a pencil, go ahead and mark the center of the line to cut, and then carefully trace both semicircles in the center, as well as the LCD section. After you're done tracing these, I'll throw up a screenshot of the exact measurements that these templates are to be at. If your measurements don't line up to that, then you can adjust your lines accordingly. That's why using a pencil might be a little bit better of idea instead of a pen, which is I'm using here. And you want to make sure that your lines are precise enough. So those are, you can freeze it and look at the lines, and that's how your dimensions need to add up. So follow those carefully before moving on to the next step. Okay, in the next step, we're going to want to cut out a little notch in the back piece to allow the extension cord that will power the internal devices out of the box. So this doesn't need to be as precise as the pieces on the top, But basically, we can mark a line right down the middle of the back piece, which is 7 inches, and just mark a line 3.5 inches, and put about 1/4 of an inch to the left and right of that, and then go up about 1/2 inch to about 3/4 of an inch. And that'll leave enough room for the extension cord to pop out. And then for the front piece, we'll want it to be as precise. So we'll start off with a 1/4 inch line from the bottom and draw that across. And then the box itself will be 1.5 inches high, 1.5 inches tall by 3 3/8 wide. And then on either side of the box, there'll be a gap of 1 13/16 of an inch. So in this point, there's images on the written directions, so just go to this step and click on the image, and I have an image where you can see those dimensions out, and you can follow those and make sure that they are accurate enough. And here's a screenshot of, like I said, what you want to start with. And once you have that done, we can take our pieces out and all our measurements and begin cutting. For the buttonhole, I use a 1/4 inch drill bit, and the button itself is a little bit longer than 1/4 inches, so you can just run your drill around to widen it up a little bit. And then I place some initial 1/4 inch holes, 1/2 inch holes onto each piece, just to allow my drill jigsaw to go through. And then slowly go through and just cut around all the lines that you made. Like I said, specifically for the top piece as well as the front piece, you want to make sure that your dimensions match up precisely with the measurements that are in the written directions. Eventually these holes will need to line up perfectly for the feeder and the ramp and everything else, so if they're off by a large amount, then everything isn't going to fit correctly into the box. So after I cut out the hole on the front piece, I can move on to cutting out the little notch on the back piece. And then for the first step of the top piece, before cutting it in 2 pieces, I'm just cutting out the LCD rectangle. And once that is complete, I will cut down the middle, splitting them in half, before moving on to the next step of cutting out the semicircles on both pieces. There are various ways to do this. If you have a jigsaw, you can use a jigsaw. There are some smaller saws that allow you to maneuver in a circle. You could use one of those as well. I ended up buying a router from a friend and was able to use that, which makes pretty easy work of it. So if you have a router or are able to borrow one, that's a nice handy tool that you can use. So I'll start off by just using the jigsaw to take the majority of the semicircle out, and then use the router to clean up the edges along the lines to make sure that the circle is perfectly cut on both sides. And like I mentioned before, you definitely want to be wearing safety gloves and glasses and some protection to not inhale in any of the wood particles. And just take your time when doing this, however you go about deciding to cut it. And if you do happen to mess up or your cuts aren't as precise as you want, there should be plenty of room left over on the second board to make another piece. As you can see, I'm working on the leftovers of the second MDF board, like I mentioned before. So if you mess up on a certain piece, don't worry about it. You can just follow the written directions and just create a new piece and cut it out, and you should be good to go. That's especially true once we start fitting these pieces together. If they don't fit as well as you would like, then just start over and start with a new piece, no big deal. Here I'm just putting the finishing touches on both of these pieces. And once those pieces are done, we can move on to the next step and just do a dry fit to make sure everything is fitting as expected. So here you'll see I have the two top pieces, and like I said before, the circle will hold the button, and then the rectangle side itself will hold the LCD screen. So we'll just do a dry fit of each one of these. Like I mentioned before, I used a 1/2-inch drill bit for the button, which is a little bit too small, so I end up just kind of running through some sandpaper, or just run the drill bit around to open the hole just a little bit more. And at that point the button should be freely in the circle and be able to press without it being stuck at all. And then eventually we will fasten this down with 4 screws on the corner, but for right now we're just doing a test to make sure everything fits properly and that the button clicks smoothly. So that looks good on that side. And now we can go ahead and test the LCD screen. The LCD screen has 4 holes already built into them, so we'll eventually be screwing those down. And then you'll also notice on the left side of the LCD screen there's a little part that kind of sticks up a little bit. That'll prevent your LCD screen from being completely flush. It'll wobble a little bit, and we'll address that in later steps. Right now we're just fitting it to make sure that the LCD screen fits into the cavity. You want it to fit up to the point where that white protruding part on the one side is flush against the bottom. And if it isn't and it doesn't fit, it's no big deal. If it's just a little tight fit, then you can sand a little piece over to make it big enough. And if not, you can just use your saw and widen it enough. Basically, you want the LCD screen, just the black part of the LCD screen, to protrude through. And you also want to make sure that the drill holes that are on the back actually have wood underneath them, so we have something to screw those to when that time comes in the future. And like I said before, that white part wants to be flush against the wood, and it will be a little wobbly right now because the white part is higher than the other side of the LCD screen. So that's normal for now. We just want to make sure that the fit is tight, and that's how it will look like once it is screwed down and everything. So for now, that's all we really want to test before moving on to the next part. And like I said, if yours don't fit tight or they don't line up correctly, just cut out a new piece until they both fit. So for now, we can put the button LCD screen back to the side, and we can move on to the next step of actually starting to construct the box itself. And to construct the box will take a little bit of time, because we'll be gluing one piece down, letting it dry, and then gluing another piece. But this is the easiest way to do it to make sure everything is lined up correctly and flush and oriented. So the first 2 pieces we'll do will be to glue the left side of the box to the bottom piece of the box, and we will glue it with the left side being along the outside of the back piece. We don't want the left side to be on top of the bottom piece. We want it to be flat along the outside part of the bottom. So we'll go ahead and just run a bead of glue along the outside of the bottom piece before lining up the left side and letting it dry in place. It's helpful if you have some things to ensure that the pieces are square. Here I'm just using some shelving. And anything you have will be handy. If you have a speed square, which I have, I'll probably be using that later on in the video. You can do that, but anything to make sure that the 2 pieces dry in place and square is what you want to use. And once that's finished drying, we'll move on to the next step of gluing on the second right hand side of the wall. And like I mentioned before, I eventually dug out my speed square, and that's the easy way to make sure that your wall is square to the bottom. And it also helps prop up the left side of the wall to make sure that it dries correctly and in the right position. And once that is done drying, in about a half hour or so, you can move on to the next step, which is gluing the right hand side to the outside of the box. And once again, we'll just run a bead of glue along the bottom to the outside of the bottom piece, or the inside of the right hand side, doesn't really matter, and just line it up. Both pieces should be the same length, so they should be completely flush. And then the speed square won't fit on the inside, so we can just line it up along the outside and just make sure it's nice and level and flush on both sides. If they're not flush, before gluing it down, you can just go ahead and trim the piece. But if your measurements and cuts were correct, they should be pretty flush. And just let that dry before moving on to the next step, which will be gluing the front side of the box. Now that the both left and right side are dry, we can move on the front. And the front piece will go on along the edges of the left and right side as long as the bottom. And the front piece itself should line up flush with the bottom piece. As you noticed before, that the hole starts 1/4 inches from above the front piece, and the bottom piece itself is 1/4 inches. So the front piece hole should line up flush with the inside of the bottom of the box. And despite how much we tried to keep the outside sides flush, they might have just bent in or out a little bit while they were drying. So having some tape handy after we glue the front piece down, we can tape it into the position that we want. So when it does finally dry, it'll be completely flush. So we can just go ahead and put some glue on the outside. And you'll notice here, like I said, mine bent in a little bit, which is no big deal. We can just pull it out and just tape it in place so it dries flush along. The front piece should be flush along the sides as well as the bottom, as well as the inside of the part. And once the front piece is done drying, you can take the tape off and proceed with the back piece. The back piece will be held on by magnets using the 8 tabs that we cut out earlier. There'll be 4 tabs for holding on the back piece, and then 2 tabs for holding on each one of the top pieces. And since we're not gluing the back piece in place, we first want to line it up and tape it down with some clear tape. And this is just to make sure that while we are lining up our magnets, that the box doesn't move on us, the back piece doesn't move on us and mess up our measurements. So go around and make sure you tape the back piece down so that it is very secure and won't move around at all. And then we can go ahead and start preparing our tabs and our magnets to hold the back piece in place. And the tabs will go about 1 inch from the top of the box along the back piece and 1 inch from the bottom. So here you have 4 of the tabs and 4 magnets. They're kind of spread out because the magnets are pretty strong and have a tendency to attract to each other. So using some super glue, we will glue down each magnet to the tab. And the tabs are a little bit longer than they are wide, so we want to glue the magnet toward the center of the tab, if not a little bit to the outside of the part. But basically we want to make sure that we put it in the center, and eventually we will take the long part of the magnet and glue it onto the back. But first things first, we want to go ahead and super glue each magnet down. And always with super glue, make sure you're very careful. It dries super quickly and can easily stick to your skin, so be very careful. If you have any gloves, it's usually not a bad idea to wear some. But you just want to go ahead for now and glue each magnet to the center of the tab. And give those about a half hour or so to fully dry. You want to make sure they're fully dry, because in the next step we will be attaching a second magnet, and if they're not fully dry, the second magnet will be glued onto the first one. We do not want that. We want for now to have the second magnet be easily detachable. So make sure that the magnet is fully attached to the tab itself before moving on to the next step, and it is fully dry. And once those are fully dry, we'll go ahead and take another magnet, and we'll take one magnet and attach it to each one of the 4 tabs. So the tabs will have one magnet that's been glued on, and then one magnet that's not been glued on. Just attract it to the one that's glued on. And we'll do that for each one and put them aside. Like I mentioned, if they do get stuck together, make sure you take them apart so there's just one loose one on each of the tabs. And then, like I mentioned before, we're going to want to glue these onto the side of the box, about an inch from the bottom and an inch from the top. Now we're going to take the long side of the tab and glue it onto each side of the boxes, an inch from the top and bottom. And once those are done drying, we will mark where the second magnet is and end up gluing that second magnet onto the back of the box. But for now, we just want to take some wood glue and about an inch from the top, put it flush along the side of the box, and then press it up till the second magnet is firmly against the back of the box. So we want to make sure the tab is along the sides, and then the second free floating magnet is touching the back of the box. And we want to go ahead and do that all 4 times and make sure that the tabs are fully dry before moving on to the next step. So just go ahead and do the last one here. I'll speed things up a little bit. And then as you can see, like I said, the tab is against the side of the box, and then the second magnet that's touching right now, that's the back side. And then here's a better angle. The tabs are on the side, and the second magnet is flush against the back piece. And then once those are done drying, we want to mark as best you can with a pen just about a semicircle around each of the magnets, just so we have a spot so we know where to glue the magnets on. It'll be hard to trace exactly around the second magnet because the tab will be on the way. If you have a thin pen or pencil, you might have a better chance of going fully around, but just making a little bit of a semicircle around each one will be sufficient enough to know where to put the magnet. So go ahead and mark each 4 of these. And like I said, we're marking the second magnet along the back side of the box, just so we have an idea of where to glue the second magnet down. So make sure they're visible on the back side of the box, and then go ahead and remove your tape so the back side is exposed. I didn't realize I was recording here, so you'll notice some extra glue is on the back piece. I had to take them off so I could start over again. But basically, after I took the tape off, you'll see my 4 lines are marked for each side of the magnet. and then we'll go ahead and glue each magnet down into their corresponding spot. You want to double check that you're gluing the magnet in the correct polarity to the corresponding piece that's on the back of the box. You don't want to glue it opposite, and then will be repelling each other. So as you'll see here, I often double check to make sure that the magnet is in the correct orientation, so then they will attract to each other in the specific spot. So as you can see, the back piece will be going up, so the bottom right hand side of the box is going on the bottom right hand side of the back piece. And then I'll go ahead and just do each one of these, and again, let this fully dry before testing, because you don't want them to get ripped off. So once those are nice and dry, we can do a test fit, and as you can see, if everything goes according to plan, those should snap right into place, and it should be very firm. As you can see, we did a pretty good job on this one. The top pieces are flush, and that they all are snapped into place correctly. And it's also easily removable, and it gets attracted back, no trouble. So now that that's done, we'll go ahead and do the two top pieces, which is a very similar process. We'll start off with the tabs again and glue one magnet onto each one, and make sure that they are fully dry before proceeding on. And for the top pieces, we're going to stick one of the tabs onto the actual back piece, and then we're going to stick one of the other tabs toward the front of each side. So one of the tabs will be along the back, and then another one will go along the side. It'll make more sense in the following steps as these tabs end up drying. And once they're dry, go ahead and put a second magnet on both of them. And then, like we did with the back piece, it doesn't hurt to tape down the top pieces right now to make sure they don't slide around while we get our measurements, because we want to make sure the magnets don't move around or in the right spot. So go ahead and make sure that both pieces are taped down quite well. And once you have the top down secure, go ahead and, if you did put any tape on the back, you can go ahead and just take that off. Because we will remove the back piece just to do the side pieces. It just is a little bit easier to film that way. You don't have to do this, it's just a little bit easier for me to show you how to do it. So once you're sure that the top pieces are in place, we can remove any of the tape holding on the back piece and then punch it out from the inside, disconnecting the magnets. So now we have the two top pieces held in place by tape, and we can go ahead and side fit both magnets that are on the side. And to do this, I'm going to flip it around. I think it'll be a little bit easier to show you this way, but we're going to stick it and we're going to stick the tabs about 3 inches from the front of the box, as you can see here, just behind the LCD rectangle and the button, but before it kind of narrows down to the semicircle, pretty much toward the top of the circle itself. And again, we want to glue it to the side, and then the actual two magnets are flush against both of the top pieces. And we want to go ahead and make sure that those dry completely. Another thing to keep in mind is make sure you don't put too much glue on it that that glues the two magnets in place. And then go ahead and mark a semicircle around each one of the magnets, as you can see I did here. And once that's dry, we can go ahead and put our back piece back on, because we will need that, because we will be attaching the last two tabs to the back piece itself. And those will go about an inch from the center line on both of the pieces. So go ahead and just tape the top piece back down to make sure that it is in place. And like I said, we will want to put them about in the middle, or about an inch from the center. It doesn't need to be as precise on this one, but it's easier if you turn the box in this orientation, with the front facing up and then the back along the table, and then gluing the long side and gluing it against the back piece. So again, the second magnet is flush with each of the respective sides. So you want to do one on one side, the button side, and then one on the LCD piece. And as you can see here, now I'm looking at it from the other angle with the top with the circle, and you'll notice that the magnets are flush. And once those are done drying, we can go ahead and mark where the second magnet is along the top piece with a pen, just a little semicircle like you see here. And then once that's done, we can go ahead and remove all the tape that's holding on the top pieces. Make sure there's no tape left on anywhere. And we can go ahead, just like we did with the back piece, we'll go ahead and remove the second magnet and glue it down each of the four to the marks that we made on the top of the box. So we can put the box just off to the side for right now, and you can see our four marks where we marked each one. And then same goes for here. I'm going to glue each one of these down, paying particular attention that the magnet is in the correct polarity to make sure that they're attracted to each other and don't repel each other. So I'm going to take each one and make sure that it's in the right direction before super gluing each one of them down. And like I said before, make sure that the super glue is completely dry before moving on to the next step and testing this, because you don't want the super glue to dry and then end up sealing both of the magnets together. So give it a few hours to make sure that everything's nice and dry before testing. So go ahead and put each magnet down. Give it a little press to make sure it's in the right spot along the intended marks. And once those are done drying after a certain amount of time, and we're sure that there's no leftover sticky residue, we can test to make sure that our fits line up correctly. So the first one should line up pretty good, and then the second one looks pretty good as well. You can tell the side pieces are still flush on the sides, and on the front and the back it looks pretty good, so this is pretty good. And like the back, it should come off pretty easily. And to put it back on, we'll put the back piece on first, and then each one of the top ones, and they should all snap in place and be nice and fit. So the next section will be, now that the box is complete, will be to build the ramp itself. And just like with the top piece of the box, there's a template that can be taken from the written directions for the side pieces of the ramp. And the side pieces are both the same, so you can just cut out one template of the ramp. And then on the other side of the dotted line, there's a template for one of the braces. We'll get into more detail of what that does later, but basically those holes will be used to hold the motor in place when it's against the feeder itself. So we can go ahead and cut the ramp out and put that aside, and then cut out the brace template itself and put that aside for right now. We'll use it in a little bit. And then we want to trace out the pieces needed for the ramp. So trace out 2 of the ramp templates that we just cut out. And then the food will slide down the main body of the ramp, which is 9 inches by 3 3/8. And then we need 4 braces, which are 3 3/8 by 1 5/8. Okay, then like before, we just want to go ahead and cut out all these pieces using a saw of some sort. A regular hand saw works fine. I'll continue using a jigsaw here, just is because what I have. And as before, you want to make sure that you're wearing gloves and eye protection as well while you're making these cuts. And just to clarify, previously both the ramp pieces were inverted on the board itself, just to save some space when making the cuts. The 4 braces will be used to construct the ramp. The one will hold up the motor itself, and then the other 3 will be used as stability to hold up the sides of the ramp and the ramp itself. So we'll cover that in the next step, but for now, just go ahead and make your cuts as precisely as possible. The middle of the ramp itself will fit pretty snugly in between both of the sides, as we'll see later, so you want to make sure that these cuts are measured and as accurate as possible before going ahead and moving on to the next step. So just make sure you measure out the pieces correctly and cut as precisely as possible. The sides of the ramp themselves will hold up the Raspberry Pi on the middle section of the ramp, and then the top of the ramp is where the motor will sit, and we'll cover that all in the next section. And again, just like before when setting up the box, when setting up the ramp, it'll be helpful to have something prop up the sides of the ramp as we glue down the braces to make sure that they're as square as possible. And when finishing up the sides of the ramp here, just make sure on the angle side itself that you make sure that the angles are accurate enough. And then the inside cut, which will hold the Raspberry Pi itself, that doesn't need to be as accurate, so you can roughly cut the inside of that, and you can trim that up later with some sandpaper or whatnot. As you can see here, I'm not spending as much time, and I just break off that one section. It doesn't need to be as accurate. And once those are done, just make sure that they're both pretty even. And if they're not flush or flat on the bottom, you can sand them as needed. And we'll end up with 4 braces. And then the ramp itself for the food to slide down, as well as the side pieces. So now that we have those set up, we can move on to the next step, which is constructing the ramp. And to construct the ramp, the first thing we want to do is we'll take one of the braces and we'll glue it onto the top piece sticking out of one of the ramps. And we don't want to stick it on the top, we want to stick it flush on the inside part of the ramp. And we also want it to line up nicely with the end part that's sticking out. So we'll go ahead and glue that down and wait for it to dry before gluing on another brace and waiting for it to dry, and then going ahead and gluing down the other half of the ramp to hold it in place. And it's not a bad idea to have some clear tape nearby after you glue it down, just to hold it in place so it stays upright. So go ahead and take your wood glue and you want to press it down so it lines up flush along the top piece of the side and all the way against the end of the piece that's sticking out on the ramp. And then you can use whatever tool you have handy to make sure that it is square and standing up straight without any leaning one way or the other. This will come in handy when attaching the second side of the ramp. So we'll go ahead and just let that dry. Now once that is done drying, we can go on with the second brace of gluing it down to the one side of the ramp. And just like the first one, we want to glue it on the inside so it is flush with the top of the side ramp. And we want to glue it about a 1/2 inch from the inside of this shelf itself. On the top one that's done gluing, you can tell it is flush with the end of the piece sticking out. But on this one, we want to have it inset a little bit, just because it helps balancing the Raspberry Pi a little bit better. Instead of having it back heavy, it can sit right on the middle piece and then go all the way back into that inset. So just like before, we want to put some glue down on this and then have some sort of level or square to make sure that it dries upright. And we want to go ahead and you can go ahead and tape that in place just to ensure that it stays up correctly, and just let that piece dry before moving on to the next step of connecting the other side of the ramp. So once both of these are dry, we can go on and attach the other side of the ramp, and we want to attach it in the same spot that we did for the first 2 pieces. So the top ramp piece will be flush against the top piece that stands out to the end, and then the second brace will be about a 1/2 inch inset in the same position. And while we're gluing these down, I'm just using the third ramp as a measure to make sure that they don't get glued inwards or bowed. So I'm just putting that third one just as a spacer to the end. We don't want to glue that down for now. We're just using that as a way to make sure that everything is lined up correctly and square. So we want to just go ahead and put some glue and line them up like I just said, and make sure that they are firmly dry before moving on to the next step. If your pieces kind of bowed or were not perfectly straight while they were drying, now's another good opportunity just to use some tape and to kind of flex them into the right spot and tape them down while the glue is drying. You still have some flexibility to make sure that they're in the right spot. And we just want to make sure that both pieces are flush with the top part of the ramp on their respective side. So after you do that, if it's not, then you can flip it over in this section and kind of tape it down into the spot that you want it and make sure it dries in that position. Mine are pretty good, so I can leave it like that, but if it doesn't, you can tape it into your position. And once that's dry, we can move on with gluing on the last step. So these two pieces are done drying. You can see they're flush with the top on their perspective sides. And then on the last one, just to give the ramp some more stability, we'll end up gluing this bottom brace piece down. And we want to glue it about 1/4 of an inch, or sorry, 1 inch from the back. So you'll see I have that marked. And then I'll just line up the piece and mark it the edge of the ramp on that outside score with a pen, and we'll put it into that position. At this point, the ramp should be pretty stable, and if it's square, then this piece should barely fit in correctly. So we'll just do what we did with the first ones, and we'll glue the first piece down, and once it's done drying, we can lift up the other side of the ramp just a little bit to get some glue in, and then we'll glue the other side down. So for now, we'll just stick the bottom piece in, and since the fit is tight enough, the ramp piece on the top should hold it in place perpendicularly enough. So we just want to line it up correctly so it's flush with the bottom of the ramp, and then go ahead and let that dry. And then once that's dry, like I said, it'll have just enough flex in it to get some glue in there, just to glue the other half of the piece to the other side of the ramp. And be careful not to flex it too much so it breaks, but you should be able to open it just enough to squeeze some glue in there. And once that's done, just like with the other two pieces, make sure it is lined up flush with the other side of the ramp and make sure it lays flat. This is the piece that'll be laying on the bottom, so if it's not flush, it'll be a little wobbly, which won't be ideal. So make sure that it is lined up, and again, you can use some clear tape if you need to hold it in the correct position. Okay, now that the bottom piece is done glued, we can move on with attaching the ramp. And the ramp should fit in very snugly to the point where you almost have to kind of wiggle it in to get it into the right position. And the ramp itself will be sitting at an angle, so it'll be right underneath the feeder where the food comes out at the bottom of the dispenser itself. And before we move on, we just want to make sure that our pieces for the ramp do line up correctly. So when you put it onto the inside of the ramp, you should notice that both sides of the ramp line up on either side of the feeder exit hole, as I showed briefly there, and that the front sides of the wall should line up against the front of the box itself. So just to get an idea of how this will look, with the ramp in place, with the walls flush against the side, the feeder will go in like this, and the rest of the electronics and ramp, once it will be built, will sit on those perspective ramps, or the perspective braces of the ramp itself. And now is also a good time to make sure that the fit is as expected and that the hole's big enough for the feeder container to go through the top, and that the ramp itself is sitting flush against the inside of the box, and that the walls line up along the sides. So that was just a quick test before moving on to gluing down the ramp itself. And this step is a bit tricky to do from the inside of the box itself. So it's kind of helpful to simulate getting the ramp into the right spot by setting up the condition outside of the box itself. So this is what I'm doing now. So the ramp itself will sit 1/4 inch from the inside of the box. So if we're pretending that this is the inside of the box, I use the ramp itself to measure off 1/4 inch from the bottom of the box, which will be the piece that I have on now, and I'm taping down the ramp just so it stays in place, so we have an accurate measurement. Getting the ramp at the right angle and keeping it glued in place might be a little tricky, so you need some patience to make sure that the ramp is steep enough for the food to fall out of, but also does not go too steep on the ramp to the point where the bottom lip of the feeder itself is pressing against the ramp. So you just want to, and this can be done from the inside of the box, but it's easier just for filming purposes and probably for yourself just to do what I'm doing here and replicate the inside of the box outside, just so we have more of a space to work with. So set up the ramp a 1/4 inch from the bottom piece of wood that you have, and you should still have some spare wood from cutting out the ramp. So once that's taped down to a spot, we want to slide the ramp up and press it to the point where it's touching the back side of the feeder. So the feeder comes out on a tapered circle, and we want to make sure the back of the ramp is touching the back of that circle. You can kind of see where my hand is right now, and we want to extend it past the back of that circle by about 1/4 inch. So you can see where my left hand is now. There's some wood sticking out just past that. And once you have that general idea, what I just showed, it's helpful to have some clear tape at the ready, because we're going to want to do this again, and then tape it into position to the point that we can glue it down. So now we want to take some wood glue and run it along the sides of the ramp. And like I mentioned before, this ramp is a tight fit, so when you get this ramp into correct position, we're going to lose quite a bit of glue rubbing against the sides, but it's okay. We can come through, and if there are any spots that are missing, we can try and fill in the holes later. So with our glue on, we can get the ramp back up into the position that we had before, so that it's touching the back side of the exit hole of the ramp with about 1/4 inch left to spare. And you'll also notice, since I have the wood on the bottom, we want the exit of the ramp itself to sit slightly past the bottom of the exit, as you can see. So we have about 1/4 inch past the top lip, and then we have about 1/4 inch sticking out. So it's not touching the table. It's just about touching the table, but it's past the bottom piece of the ramp itself. So about on either side, we have about 1/4 inch sticking out either way. And if it's cut correctly, then the piece sticking out on the bottom should not be touching the ground, and the 1/4 inch on the other side should be enough to cover the food from not bouncing off and out of the ramp when it comes down. So when you have it in this position and the glue is in place, we just want to go around and stick some tape just so it dries in this position, because if you let it go and it's not as tight as a fit, the ramp will move slightly. And like I mentioned before, this part is kind of tricky, so you want to go through and make sure that you do it correctly. And if you don't get it in the right position the first time, you can just, no big deal, just take the ramp out and wipe off some of the glue and give it another shot. It will take a couple times, but just be patient and make sure that you get this step correctly, because we want the ramp at a steep enough level for the food to come out, and also have enough of the ramp sticking past the feeder, so when the food does come out, it doesn't bounce out of the ramp and into the box itself. And then we also want enough of the ramp coming out on the bottom, so the food itself doesn't just dribble out of the box and won't fall onto whatever plate we have on the outside of the ramp. So once we have it in position, just want to tape the pieces down. And once the glue's done drying, like I said before, if there are any gaps that were missed from sticking the ramp up, you can go ahead and just run some glue along the sides to kind of refortify it. As you can see, that's what I did here. On the bottom side, there was some gaps where glue didn't fit in, so I ended up just sticking some glue and running it down the side to kind of reinforce the ramp itself. As you can see, it's still kind of drying. And You can do that if you don't feel that the ramp is strong enough to be held in place. There isn't going to be a lot of force on it, but it's just something to keep in mind. So then we can move on to the next step of constructing the motor. And the first thing we want to do is to take the piece that we had before and to break off the stick itself that's attached to the wheel. We want to go through and break it off as far down the handle itself to keep the longest possible piece. And we don't need the handle itself, we just need the white stick that I just broke off. So we can get rid of the handle, but keep the actual rod itself. The rod is what is most important. And try to break that off as far down as possible to get the longest possible rod. And then once that's done, we can take our template that we cut out earlier and we can tape it on top of the last brace that we have left. And this template will be used to keep the motor in place while it's attached to the ramp. The motor is quite strong, and when it spins, it's going to want to spin itself. So this template will be handy to keep the motor screwed down, and then this brace will be screwed down itself to the ramp. So once the template is cut out and taped onto the front of the brace, we want to go through and drill the 6 pilot holes around the ramp itself. And then a pilot hole for the center hole itself. And then once that's done, we can discard the actual ramp template itself and make the holes bigger. And the final hole size for the 6 outside pieces, I used a 9/64 inch drill bit. That's the one I'm using now. And then for the center hole, be using a 1/2 inch drill bit. And like the ramp, this is something that's you're going to want to make sure is pretty precise. The holes will have to line up pretty perfectly with the holes on the motor itself. So if these are, you will have some leniency using a 9/64 inch hole, but if you got to the point where the holes don't line up, and we'll see this in the next part. If the holes don't line up, then it's no big deal. Just cut out another brace piece and use the trace again and make sure that they line up correctly. Otherwise, the motor won't sit snugly against this brace piece, and it'll kind of move around too much to be effective. So after we finish the outside 6 pilot holes, we want to go ahead and drill the middle piece out to about a 1/2 inch. And we can sand out any extra loose pieces that are left over. If you're at the point where, and again we'll cover this in the next part, it'll make a little bit more sense, but if this piece is not perfectly lined up, there is some wiggle room to make the holes a little bit bigger to keep the motor secure. And this is how the motor will sit. The center part, which spins, will go through the middle section, and you'll see that the 6 hexagon sides will line up with the 6 hexagon screws that are on the motor itself. And we want to just make sure that the part that actually spins on the motor, which is the rod that sticks out, has enough freedom to rotate and doesn't rub against the wood in any way possible. And also can sit completely flush through. And if the hole's not big enough, then you can just use your drill to kind of widen the hole a little bit with some sandpaper as well. So now that those holes are drilled, we want to go through and use these number 4 40 by ½ inch screws to fit in the motor itself. Finding the right screws that are threaded correctly to go into this motor are pretty tricky, so I put a link in the description below for the best ones that I found. These aren't perfect, but they're good enough to hold the motor in place to make sure that it doesn't move while we attach it to the rest of the feeder. And then we just want to go ahead and with the piece on, line up each screw and just slowly turn in each one. It's a little tricky to see where each one lines up once the front brace is on, so having some sort of flashlight to actually show where the hole is on the back side could be kind of handy. And the screw that I'm putting in right now, you want to be careful on. I've had some issues in the past where if this screw is too tight, it'll shut off the motor. I haven't figured out the root cause of this yet, but it's the screw at about the 3 o'clock position. When you do tighten that one down, make sure you don't tighten it very tight. Otherwise it'll cut off the motor and it'll be very difficult to troubleshoot. So then go ahead and line up the rest of the screws and just turn them in just a little tight, and then once they're all in place and lined up correctly, then you can go ahead and tighten them all down, paying close attention to the one in the 3 o'clock position, not to screw it down too hard for risks of stopping the motor. And you don't even have to screw them all the way down into the holes itself of the motor. I think eventually you'll see mine, there is a little bit of gap between the brace and the motor itself, but as long as all 6 of them feel tight in place, it should be good enough. And like I said before, if yours don't line up for whatever reason, if only one of them doesn't line up, you can probably continue with it as is. It'll probably be secure enough to hold the motor. But if your holes are all well off, it's no worries. Just cut out another brace piece and drill the holes again to make sure that they lined up correctly. I try to give a template that lines it up as best as possible, but it's kind of hard tracing it on and drilling holes. There is some margin for error. So as I mentioned before, I'm done screwing these down, and there is a little bit of a gap between the brace itself and the motor, but it's no big deal. The 6 screws are holding it in place, so it'll definitely be strong enough. So in the next step, we're going to go ahead and take 2 braces, L brackets, and screw those down to the side, and then eventually we'll use machine screws to hold those in place onto the actual ramp itself. But before we do that, we want to attach the coupler to the motor, and the coupler will hold on the piece that'll go into the feeder, and then we'll attach to the motor itself. And the motor rod as well as the white feeder piece both have one flat side. You want to line up those flat sides onto at least one side of the screw itself to allow it to have the most possible torque. And if one of those inside screws come out, then you can just put them back in as you just saw that I did. So each side has 2 screws. You want to line up one flat side to go directly onto one of the screws, and then one flat side of the motor to go on another side of the coupler. And the motor will go on the smaller side of the coupler, and again, the link is below for the exact coupler size. They come in dozens of different sizes, so you want to make sure you get the correct one. And once the flat side of the motor is lined up along one of the screws, you want to screw that down, and then go ahead and screw the other subsequent screw against the coupler itself using just a regular Allen wrench. And once that is tightened down, then you want to go ahead and do the same thing with the feeder stick, I guess it is itself. Again, make sure it's flat against one of the screws and tighten it down. Now the stick itself is plastic, so it'll be a lot easier to clamp down on the screws itself than screwing it down onto the metal motor itself. So you can really clamp down on this to make sure it is tight. And once you have those four screwed down from the coupler, they should be tight. You should be able to tug on it and make sure that nothing's loose and that it's all securely in place. And once we are certain that it's all one piece, we can go ahead and move on to the next step, which will be setting this up inside the ramp, inside the feeder dispenser itself, and having it sit on top of the ramp and held in place by the two L brackets, which I briefly mentioned. So we'll go ahead and do that in the next step, but just to give you an idea of how this will go, we'll want to slide this. This will fit in against the flat side of the feeder flapper itself, and it will sit on the top piece of the ramp. It might not sit exactly flush with the top piece, but that's where the brackets will come in handy to make sure that it stays in one piece. And the brackets will go on either side. Okay, now we can go through the process of getting these L brackets set up correctly to hold the motor in place. So the one thing you want to take note of is now that the ramp is hanging off a little bit, you want to make sure, since it will sit against the board, you want to make sure the bottom of the ramp is slightly overhanging the base piece that's sitting against the table. Otherwise the ramp will be kind of angled up and it won't provide with an accurate measurement. So you want to make sure that that's set up correctly. And then you want to go ahead and take each L bracket and mark the holes against the motor brace on either side. Now on the right hand side of the motor we will stick the power plug, so try to stick the one on the right hand side as close to the motor as possible, and on the left hand side it's not as important where you stick it. You can stick it anywhere along the brace itself. So once we have those holes marked against the motor brace piece, we'll want to go ahead and to screw the L brackets down using the screws that come with the brackets. And these are inch brackets with 2 mounting holes. You could probably get away with just a 1/2 inch bracket, which only comes with 1 hole on each side, but obviously that's not going to keep it as secure as a inch bracket, so that's what I'll be using. So just go ahead and drill small pilot holes for each of the 4 mounts onto the brace itself. And once that's done, just go ahead and get the brackets screwed on with the screws provided and a Phillips head screwdriver. Now to make this motor and feeder box itself as simple as possible to disassemble and reassemble, we will be attaching these brackets to the motor brace itself, but we will be attaching the bottom of these brackets to the ramp just using a regular bolt and machine screw. So after we're done securing the top of these L brackets, we'll take the bottom 4 holes, line them up against the ramp, and drill 4 pilot holes, and then we'll use some machine screws to hold it in place instead of using regular wood screws, so that if we ever need to take it apart in the future, we don't need to take apart these 4 screw holes right now. We can just remove the 4 machine screws that are attached to the ramp itself, and that'll make more sense in the following step. So for now, just make sure that these 4 are tight, and while you're screwing them down, the bottom half of the bracket should be pretty flush against the bottom of the table board on the table. And once those 4 are done, like I said, they should be pretty flush, and the motor itself should be sticking off the table a little bit. That's fine, that's normal. The motor itself can be suspended in midair, the bracket itself is, and then the front 6 screws are what'll be keeping it in place. So now, like I said, we'll go on to the next step, and we'll bring the feeder back. And like I mentioned before, we want to make sure the front part of the feeder is sticking over the edge, so it is flush, and you'll know this, the bottom of the ramp is flush. And then we want to stick the rod back in to the actual ramp, make sure it gets all the way in, and then we can go ahead and mark our 4 pilot holes onto the top brace of the ramp, and make sure everything's lined up nice and square and correct before moving on. We want to make sure that this is angled correctly and everything is precise. And like I mentioned, the motor and brace itself might be hanging in the air, but that's as expected. The brackets itself will hold it in place. And then we want to go through, and once everything's aligned properly, we want to go through and just, with a pen or pencil, just mark the 4 holes that we want to drill into the top brace of the ramp. And like I mentioned before, we won't be using the rest of the screws provided with the brackets itself. We'll be using some machine screws to allow us to take these pieces on and off more easily in the future. And I ended up just using some inch long number 6 machine screws, but you can get away with a 3/4 inch one as well, or possibly even a 1/2 inch, not sure, but I'll be using an inch for this example. So we'll go ahead and start a tiny pilot hole for each one of these. And be careful not like I'm doing now, since the bottom of the ramp is pressing on the bottom of the board. You don't want to break the ramp itself, so just be careful when drilling this section. You're best to have the ramp overhang the side like I mentioned before. Then just moving up to a slightly bigger drill bit. And I believe the final hole size that I end up using is just a 1/4 inch drill bit. So you'll want to drill a 1/4 inch hole into each one of these. And after you drill the pilot holes for each, you can clean up any of the extra wood with some sandpaper, or just brush it away. And once those are done, we can stick the ramp back onto the side to make sure that it's lined up correctly, and then bring in the rest of our ramp and feeder and line up the holes. Should now line up with the bracket themselves. So then we can take the screws that I mentioned before, and I just put a washer on the top and run those through each of the 4 holes. And then take the bolt on the bottom and run it up the machine screw. I'm just holding the bottom one in place and screwing the top down until it engages, and then just screw them down so all 4 of them are tight and in place. And as you see here, you don't really need the feeder itself at this point, and so I just took it and put it to the side just so it films a little bit better. But you can take it and put it aside, or you can have it in place. Doesn't much matter. Just want to bolt all 4 of them down, and it should be pretty solid at this point. And then once that's in place, if you did take it apart, you just want to stick it back in kind of at an angle, because the ramp itself should be pretty tight against the back of the ramp, and have it sit off slightly against the side. And just go ahead and make sure all 4 of them are pretty snug into place, and that should be enough to keep the motor solidly in place, so when it spins there is no movement and shaking of the feeder itself. And now that that's screwed down to the ramp, it's kind of all one piece now, so just be careful when moving it in and out of the box. And the next step is the final assembly. Now we pretty much have all the pieces that we want at this point. Now we just have to assemble them all into the box itself. And the first piece that we will put into the box itself will be the button. And as I mentioned to well back earlier in this video, we will end up screwing the button to the top of the piece itself. So the first thing we'll want to do is to take and drill 4 pilot holes on the outside of the button. If you remember, the wires run kind of down the middle, so we kind of want to stay away from that section, and we want to drill into each corner through the electrical tape and through the PCB till it comes out on the other side. And I will be using 1/2-inch wood screws to keep this in place. I'll include a link to the actual ones that I used that I showed quickly here. And once our 4 pilot holes are done, we just want to make sure that they're big enough for the wood screws to go through. And these are 1/2-inch wood screws, and keep in mind that the wood itself is a 1/4 inch. So when screwing these down, we don't want to screw all the way down, because there's a risk that it might go through the top of the piece itself and be showing through the top. So just screwing these down enough so that the button is firm in place without going through the top is sufficient. If it does accidentally go through the top, it's no big deal. You can use some wood putty or glue to fill in the hole. But if you just be careful during this step, then that won't happen. So just we want to line up the button in place so the wires run through the back to the back. And I'm taking something just to elevate it off the table, because the button itself has is sticking off the ground and it's a little wobbly. So if you just set it up the way I did, where the button is hanging over the side, then it allows it to be a little bit more secure while we drill these pilot holes. So we have the 4 pilot holes onto the button, and we have the wires running toward, if you can imagine, the back of the box. And then we just want to transfer those 4 pilot holes onto the box itself. And to be careful not to drill through the box to the top of the piece itself. So we just want to drill little pilot holes for each one onto the board, making sure not to go all the way through. And once we have those transferred to the top piece, we can just make them a little bit deeper. And for here, I just did 2 on a diagonal just to make sure the button is in place before doing the other 2. You can do it that way, or if you can do all 4 at the same time. So just line the button and PCB back in place and screw those both down. Like I said, they don't need to go all the way down. Just having 4 of them in should be significant enough to hold the button in place so that it doesn't move around at all. And once those 2 are done, you can go ahead and mark out the other 2, transfer the other 2 holes onto the top piece, and screw in the other remaining screws. And make sure that the button is secure and in one piece, which it should be. And you can tighten them down to the point where they don't go through the top. You'll start seeing them poke through the top if you screw down too hard. So if you get to that point, then just back them out a little bit. And the button should be secure, and it should have enough play, so when you press it, it actually goes down and comes back. So once that is set up, then we can move on to the next step of doing the same thing with the LCD screen, should you include it. Now the LCD screen itself already has 4 holes in place for it, so we don't need to drill 4 pilot holes like we did with the button. We just need to drill 4 pilot holes onto the piece itself to transfer the markings onto the screw. So we want to set it up so the wires are going back toward the back of the box and sitting up like I have now. I'm flipping it around just so it's easier to transfer the holes, but make sure you have it set up the way I did, otherwise when you turn on the machine the piece could be upside down, which would be no good. So you want to go ahead and press it into place, and as you remember before, there is a white section of the LCD screen sticking up a little bit. So we just want to counter something on the other side to make sure that it is level. So when we make our marks, the 4 screws are lined up correctly. And you can use anything just to hold it up. This doesn't need to be super precise. Like with the buttons, we don't want to screw all the way down because you risk putting the screws all the way through and showing through the top. So we want to make each one of our marks, and when we set our pilot holes, we want to be careful not to go all the way through. And then we want to go ahead and take our 1/2-inch wood screws and screw them down into place. And again, it should just be loose enough, should be sticking up enough just to hold the screen in place. No one's really going to be pressing on the screen or like they will on the button, so these don't even have to be as tight as the button. And after you put them in place, if the one side is a little bit more tight due to the fact that that white part is sticking out, then you can just back it out on the one side and put the screws down a little bit more on the other side to make sure that it is flat and level looking from the top. And we want to make sure that the screws didn't go through the top, which mine did not, and that this piece is strong enough to be held in place, which it is, and it looks straight and flush from the top. and that it is level, so when you look at it from the top, everything looks good. So this looks pretty good, and eventually in the next step we can address this jumbled mess of wires. You don't have to, but I'll go through the steps needed to straighten these out a little bit. Okay, this optional step of straightening out the wires is something you don't really need to do. It's just kind of helpful once everything gets inside the box to make sure that there's enough space to put the wires down. So as you recall, there is one wire on pin 3 that comes out of the LCD screen and goes to the potentiometer. And then there are 2 other wires coming out from the potentiometer that will also go into the Pi. And if you recall that the wires for the potentiometer are longer than the actual LCD wires themselves, which are 24 inches, and then the potentiometer wires are 30 inches. So what we'll end up doing is taking the 24-inch wires and braiding them down, and then once those are done braided down, we'll leave the ends a little bit flared open so they can be plugged into the Pi. And then once that is complete, we can take the 30-inch wires and run them up toward the middle of the 24-inch wires, and then take the other 2, which are going to go into the Pi, and run them down along with the other 11 coming out of the LCD. That'll make a little bit more sense coming up right here. And that's why we give it a little bit extra slack. So if you see right here, we have the 11 that are going to the Pi that I put down with to hold them in place with the scissors. And then we can take the other 2 that will need to go to the Pi, as well as the potentiometer wire, and we will run it up through the second twist tie that I have, and then I'll take those 2 going to the Pi and then run it along with the other 11 through the LCD screen. And this will allow all the plugs that are going to the Pi to be all on one line, and then it'll allow the potentiometer enough slack to be stuck in the back of the box. So if you do need to adjust the brightness, it'll be off to the side and is something that you can adjust without having to take out the rest of the box. So as you can see, those 2 other wires, I'm just running through the twist ties with the other 11 so that all the wires that need to be plugged into the Pi are together now, and the potentiometer wire itself is off to the side. So I hope that makes a little bit of sense. Again, this is a pretty optional step, but I find it pretty handy to just keep everything in order once everything goes into the box. And then as you see, everything is set up correctly and is off to one side. And like I mentioned earlier, we do want to have some slack toward the end of where they get plugged into the Pi. So we do want to back off the twist tie from those sections, just so we can see the numbers and have some space to plug them in once we continue with final assembly. And these twist ties themselves can slide up and down a little bit, so if they're in the way, you can just back them up a little bit. And once that's complete, we can move on to another optional step, which I like to do, which is to put some feet onto the bottom of the box. And the feet are helpful just to elevate, as you saw before, the bottom of the ramp itself sticks out just a little bit. So depending upon what surface you end up putting the feeder box itself, it's good to have something just to take the box off the ground a little bit, just so the feeder ramp itself doesn't press along the bottom of that surface. And for these, you just want to stick them into the corners. For the front 2 pieces, I tend to back them away just a little bit from the front, just so they don't stick out as much and show from the front. And then the back 2, you can put them more toward the corner itself. And you just want to make sure that for the back ones that they don't press up against the back piece, which is removable. And you can use as big or as small as ones that you like. For my feeder boxes, I end up putting them on a little bit of a pedestal, so my pets kind of don't have to bend down to eat. It's a little bit more helpful and healthy for them to eat at a level that they don't have to bend down for. So this can be used in conjunction with whatever else you're planning to use to feed your pet. If you have a bigger plate that needs to go under the ramp, then you can use bigger feet, or you don't have to use the feet at all. But this is just something that's helpful to elevate the box and ensure its stability on whatever surface that you put it against. And once those are in place, we can move on to the next step of assembling the pie and everything else. And the pie itself will want to stick on the second brace underneath the brace with the motor on it. And we want to make sure that we stick the pie with the power side sticking slightly out on the right hand side of the ramp. So once everything's lined up, and the power side, which is on the top right hand side as you see in the picture, we'll want to have that sticking out on the other side of the ramp, because the power plug for the pie will be stuck underneath the ramp as well as the one for the motor, and we'll plug it in from the right hand side. So as you'll see here, the right hand side of the power is sticking out on the other side, and that also allows the GPIO pins to stick out on the back, which will allow us to plug it in. And you'll notice that the ramp itself is still on covering the GPIO pin, so when it goes into the box there will be some room. And we want to stick the pie to the right hand side to leave us enough room to stick the relay in. And we'll stick the relay with the breadboard wires on the back, and the breadboard wires go inside the little on the ramp, or they could stick on the outside, kind of like the power port. And then on the top, like I said earlier in the video, we're going to stick the power plug itself to the right hand side of the L bracket on the top brace for the motor. And then both power plugs we're going to stick underneath the feeder and the hole between the ramp and the feeder itself. For the pie, I stick it perpendicular to the outlet, and then for the motor I stick it parallel, so it kind of makes a backwards L, and that's the best way I found to get it to fit underneath the hole underneath the ramp. So you can just slide it in, and then the extra wire that you don't need you can just tape up or use a twist tie or however you see fit. So I just leave enough slack for it to plug into both the power and the pie itself. And to keep the pie and the relay secure, a good idea is to Velcro it down onto the second piece. Now the pie should fit pretty snugly onto that section, but if it doesn't, you can use some Velcro. But for the relay itself, using Velcro is almost a must. Or you can use the screw holes provided, but I find Velcro a little bit easier in removing it. So to get the Velcro attached, I just wrap some electrical tape around the box itself just to protect the bottom pins. And then once I'm done with that electrical tape, I just get some regular Velcro and attach it to the bottom and take off the tape from the other side and align it with the box itself. Now the relay itself will stick out a little bit on the left hand side most likely, so when placing the Velcro we want to make sure that the bottom piece actually lines up with what's on the box itself. So after we stick some electrical tape to prevent it, we're going to want to put the Velcro on toward the right hand side of the tape itself, as you'll see here. And here I have the Velcro, and just cut a piece of Velcro out with both sides still attached, and then remove the sticky side from the one hand side and attach it to the relay. And once it's attached to the relay, remove the sticky side from the other side. the plastic that's holding the sticky side, and attach that to the ramp itself and give it some time to cure before separating them, or they might peel away from their respective sides. So go ahead and place that down and press it firmly and give it some time to cure. Now you can do the same thing with the pie itself. I'm not doing it in these directions because the pie is secure enough to be held in place, but if yours is not, just do the same steps and do it with the pie itself. And then for the power port, you could use Velcro, but I'm just going to go ahead and super glue it down at this point to the right hand side of the motor, and just make sure that you do it slightly off to an angle because it will be plugged in from the right hand side just like the Pi power, and you want to give yourself enough room to remove the L brackets and the motor in the future should you take it apart. So just glue it down at a slight angle pointing toward 1 or 2 o'clock on a clock, and once that is glued down you can plug in both of them as you see here. You can also see I have some just clear tape holding the motor in place underneath the ramp, or the outlets, sorry, not the motor. So both outlets are underneath the ramp, and I have just some clear packing tape just to hold them in place. And the white wire itself will come out the back and go through the hole on the back of the ramp, and that's what it will eventually plug in. But with our Pi and power plugged in, we can go through and attach the relay, the 3 relay pins to the GPIO slots, as well as the 2 button slots onto the Pi itself. And here I'm also going ahead and connecting the wires back to the power port and relay itself. If you took those apart during assembly, just put them back in their respective slots. If you mark them down, then this should be easy enough. And once the button and relay are plugged into the Pi, you can go through and plug in each one of the wires to the LCD screen should you have one. And if you marked them earlier with each respective GPIO pin, just find the corresponding GPIO pin and plug it in. So pins 1 and 2 will be on the closer side toward the power port, and pins 39 and 40 will be on the other side. You can just reference the pictures in the written directions themselves to get a better idea. And once all the LCDs GPIO pins are plugged in, we can go ahead and finally plug it in and make sure everything's working before shoving everything inside the box. So you can see that I plugged everything in, the screen's on, I pressed the button and the feeder turned, and I can press the button again, you can see the feeder turning and the LCD screen is updating. So that's great. So now that we have everything working, we can go ahead with the final assembly and sticking everything back into the box. And when I stick things into the box, you want to make sure that the wires for the LCD and the button don't get caught on the back side. So I typically lean the whole thing back just so the Pi and the relays don't fall forward. And then the next thing I do is I line up the bottom of the ramp with the exit hole from the box and kind of slide it through to make sure everything's in place. And keep it in mind that the wires from the button and the LCD don't get caught up on the back. If not, just pull them and lean them over the top like I have now. And then the next thing I do is to make sure that the extension cord for the 2 power outlets has enough slack to go through the back of the box, and I line up the back piece. And once that is lined up correctly, I'll do the LCD section, and there should be enough room to tuck the LCD wires down along the side of the box. So I'll go ahead and do that, as well as sticking the extra potentiometer toward the back of the box. There should be some extra space back there. So kind of tuck those in. And these wires were designed to be long enough so they can sit on the side. But they should tuck fairly nicely down along the side, as you'll see here. So then put on the LCD section, have that snap into place, and then do the same thing with the 2 button wires. Just tuck them down along the side of the box. And another helpful thing is to make sure it goes underneath the one magnet toward the front of the box, just to make sure that the wires don't get in the way when it snaps into place. I'm spending some time to do that there. And we've already dry fit everything before, so once you get the wires tucked in correctly, everything should be good to go. And we're heading toward the finish line of having this completely set up and ready to go. So now we can move on to the next step, which is an optional step, but highly recommend it, which is just painting the box itself to any color you want. As you can see, I still have a lot of measurements on this one, so painting through them would be a good step. And basically, now that we have everything working, we can just reverse these steps and go through and disassemble everything, and then paint it, and then finally reassemble it again one more time. Okay, we already went into great detail about how to assemble the box, so now I'll just go through and talk a little bit about how I like to disassemble it. So for painting, so usually I'll take the LCD screen off and make sure that the wires don't get caught on the side magnet piece, and then do the same thing with the button top piece, and then remove the back. And then just the same way I angled the whole inside piece up to get it out, I'll typically do that again, but with the box this time, kind of angle it up and slide out the whole system. And also keep in mind that I logged in to the Pi and shut it off at this point, and disconnected the power from the wall before turning it off. And as you remember, the ramp will press against the wall, whatever table you have, so just stick another piece underneath it to make sure that the bottom is supported a little bit, so keep the bottom edge of the ramp up off the table itself while we're continuing with the disassembly. So once that's done, the next thing I'll do is to loosen the 4 machine screws that is holding the motor into place. As well as removing all the GPIO pins from the Pi itself. And then removing the power from the Pi as well as the motor connection. And then also, you'll see before I remove the wires from the power port itself, because we will be painting some of the ramp, so we'll want to disconnect those as well. So then we'll go ahead and also disconnect the relay and unscrew the wires from the relay, so we can put that aside as well as the motor aside when we do painting. So once that's complete, everything should be disconnected, so we can go ahead and slide the motor and assembly out once we remove the rest of the machine screws from the near side. So I'll go ahead and do those. Make sure you put those aside for when we reassemble again. And you can paint the box any color you want, obviously. One thing to keep in mind is if you are going to do a lighter color and you use pen to mark a lot of your markings, just keep in mind you might have to do a few extra coats, because the markings themselves might show through lighter color paint. I'm going to use a darker color paint for this box, so that shouldn't be a problem. But once the screws are removed, you'll want to remove the bracket with the motor on it, and just be careful not to knock the power port loose, which I super glued on. And we want to go ahead and move the assembly with the feeder and the power ports off to the side. And then we want to go ahead and unscrew the LCD screen and button from both top pieces. Now these are held in place, if you remember, with each with 4 1/2-inch machine screws or wood screws. So just go ahead and remove those and put those 8 screws off to the side, or only 4 screws if you're not including the LCD screen in your build. And we'll go ahead and paint the 2 top pieces of the box, the whole box, the back piece, and then we can also go ahead and paint a part of the ramp that's sticking out of the front of the box. You can paint the whole ramp itself if you want, but no one's going to see it. So for my purposes, since I was running low on paint anyway, I'm just going to paint the bottom side of the box that comes out. And you shouldn't need more than about 8 ounces of paint. Usually they sell those sample paints at your local home improvement store. And usually you can get them on sale for as low as like 50 cents. So if you see a color you like in that section, you can pick up one of those, or you can get a color that you wish and get some made. But you don't need a lot to paint the whole box itself. So once the screws are removed, we can take out the LCD screen and also put that aside. So now everything's disassembled again, and we'll just reverse that step once we're done painting and assembling everything. But for now, we just want to get our pieces together that we need to get painted. And if you did include some sort of feed onto the box, you'll probably want to remove those as well at this point and put those aside. And after we're done painting, the holes should still be pretty clear after painting, so we won't need to mark anything to see where the holes were. It should be easy enough to assemble everything back together after everything is done being painted. So just go ahead and remove the feet, and then before we get done painting, you want to make sure you're in a well ventilated area, and make sure that you have some sort of drop cloth or protection to make sure anything that you have around you is not accidentally covered in paint. So now everything's completely disassembled. The feet are off. So now we can move on to painting. And so we can gather our pieces up, and the pieces that we don't need put aside, we can put those aside while we paint. If you do end up painting the whole ramp, just be careful not to paint over the Velcro, because once you paint over the Velcro, it definitely loses functionality a little bit. It becomes harder for the things to stick, so that just keep that in mind. And also keep clear, obviously, not to paint over the power port itself. But like I said, I'll only be painting toward the bottom of the ramp. And then after we're done painting the ramp, we'll move on to another optional step, which will be to put some sort of protection on the ramp. If you're worried about the food running along a painted surface, I'll show you an optional step that I often like to include. So here I'm just going through and painting the box itself. I'm not a professional painter by any chance, by any stretch of the imagination, but I'm just going through and painting everything that'll be seen from the outside. And just starting with the box itself, and make sure you get the pieces along the inside of the feeder that come out. And then while that's drying, I'm doing the back piece as well as the top 2 pieces. And you can paint over the magnets, they'll still work plenty fine if you paint over them, so you don't got to worry about that. Just make sure you get inside the crevices for the LCD screen and buttonholes itself. And once those are done drying, you can flip around and go to the bottom of the box and paint that as well as the back piece. And you do want to keep an eye on while you're painting to make sure that you don't have any drips running along the side of the box that dry like that. So you want to make sure that you spread out your paint thin enough so there's no thick spots that show up along the box. So you might have to go through to different spots, especially if you're leaning on the top of the box like I am, that there are no drips, and you can just touch those up as needed. And as you can also see, I purchased one of those big plastic cloths to put over the table and my floor to make sure that I don't spill and paint anywhere, and also just using some disposable gloves just so I don't get paint on my hands. But the paint's easy enough to get off. So once that's done and dried, you can see I just did the front of the ramp. One thing I also like to include so that the food doesn't run over the paint itself is you can take one of those thin clear plastic cutting boards, like you can see the one I have here, and I just trim out a piece slightly smaller than the ramp itself, and we can just put that on top of the ramp so the food will slide down and not come in contact with any of the paint. If you buy food safe paint, you don't need to do this step at all, but it also helps reduce the friction a little bit, so the food will come down a little bit faster if you include a thin piece of plastic on that. And then you can just tape down this piece onto the ramp itself. I had a few of these extra command strips lying around, so I'll just be using these. And basically you want to attach them to the top part of the ramp. This is the part of the ramp that sticks past the feeder hole itself. So I'll just line those up, and once those are secure, I'll just line up the plastic piece itself. And like I said, you can just go to any department or dollar store and find one of these plastic cutting board pieces. You can find ones that are a little bit clearer, different colors, and just line it up so the bottom piece lines up with the bottom of the ramp, just like that. And that should be enough to keep it in place. And with that, that's pretty much it. We just reverse the steps that we did before and assemble all the pieces in reverse that we did before. And there's really not much to it, and here's the final product. And here's testing it out. You can see everything's working as expected. And from here on out, you should have a fully functional feeder. And in the final section, I'll just have some closing thoughts, as well as a few additional features, such as the Pi camera, which I talked about earlier. But at this point, the box is pretty much complete. And like I said, we'll have some closing points that I'll touch on before ending the video. So at this point in the video, I hope you have a fully working feeder. If you do, congratulations. I hope you learned something new along the way in the process as well. If you have any questions, feel free to reach out in the comments or the email below. I would love to help out in any way that I can. I know this video is quite long, but I hope the level of detail was more helpful than not. I saw several DIY videos posted online where they only show the final product, and to me that was quite frustrating. I use this feeder every day, and I hope you get as much utility and convenience from it that I do. Before we wrap up the video, I just want to make a few other additional points, and then also attach an additional section to the end about setting up an optional motion triggered camera to the device. First, as I mentioned earlier in the video, make sure when the device is unplugged to make sure you log into the Pi via VNC or SSH and shut the Pi down properly. I have unplugged the Pi directly from the power outlet before, and this leads to the SD card becoming potentially corrupt and becoming unwritable. And having to start all over again with a new card and setting up the OS and services is not super fun. Second, if you have any ideas to improve the build or the code themselves, feel free to reach out and let me know. This system's far from perfect, and there are plenty of ideas and features that could be implemented. And the code itself is open source and is available from the link in the written directions on GitLab. Lastly, and this has not been mentioned before, there are some configs that can be tweaked on the website itself. We will cover a few of these configs in the following camera section should you include that. However, there are some configs that are helpful to the website and the feeder itself that can be accessed on the web page. So I just want to briefly cover those in this section. And to get to these configs, we'll have to open up the config file on the Pi site itself. And to get to these configs, we'll want to go to var www feeder, and there's a file there called app.config, and if you double click on that, you'll see some of the configs that I have in there. Most of these you won't want to change, such as the GPIO pins, as well as the database or log file locations. Unless you feel comfortable making those changes, you can go ahead and do it. Otherwise, the other configs are in here. A lot of them are related to the camera setup, which we will cover in the next section. But the ones that are probably worth mentioning now would be the hopper spin time, which is set to 0.6. If you want more food to come out, you can raise that to higher than 0.6 of a second. If you go any lower, the paddle doesn't do a full rotation and not a lot of food might come out. In addition, the number of feed times, as well as number of schedule feed times to display, which are 5. If you up or lower those values, more or less values will show up on the web page itself. So if you want to see a greater history on the web page, you can change those values. In addition, the seconds delay after pushing the button and the seconds delay between checks, those are for if you press the button, it'll wait 3 seconds before it dispenses another feeding, because the button service is very hair triggered. So if you push the button quick a lot, the food might come out quickly. So I have that 3-second delay. If you don't want that, you can change it. You can up it, or you can lower it, or you can set it to a lower value. If you do end up changing any of these values, you'll want to go ahead and change the value, save this config file, and then go ahead and restart Apache just to make sure everything takes effect. And to redo that, you just go to the terminal and type sudo service apache 2 and then restart. And like I said, the other configs related to the camera will be described fully in the next section. But this is just another addendum to say there is some more options that can be tweaked should they be needed. So in the next section, we'll cover setting up the optional camera that can be attached to the Pi and triggered via any motion that happens in front of the box. So before we get to the section on setting up the motion camera and live stream, I thought I would also quickly include a section on triggering a feed using the specified web request call, and also give one quick example out of many on how it can be used. The web request itself is accessed by whatever your duckDNS address is, followed by a /, followed by feed button click smart home, all one word. I will visually show you this address in the example briefly. But in this example, we will set up Google Assistant to trigger a feeding whenever we say the feed phrase that we specify. To connect to Google Assistant, we will use the popular service if this then that in this example. If this then that can help you connect lots of devices such as the Google Home or Alexa or any other hundreds of applets that they have on their site. And once the assistant is configured, whenever the Google Assistant hears the specified phrase that we mention, if this and that, we'll call the web request and trigger a feeding. So let's go ahead with this example of setting up our Google Assistant through if this and that to trigger a feeding. The first thing we will want to do is sign up for an if this then that account. So go ahead and sign up on their site, which is ifttt.com, ifttt.com. And once signed up, you will land on their main page here. And once you're on the main page here, you'll see a button in the upper corner called My Applets. So we'll want to go ahead and click on that. And the website starts you off with a default applet. We won't want to use that, so we'll go ahead and click on New Applet on the right hand side. And the first thing we want to set up is this part of the if this then that before we set up the trigger, which is the feeding itself. So in this example, like I mentioned, this in this case will be a phrase against the Google Assistant. And in this case, our Google Assistant is running on a Google Home, but it could also be your phone or any other device in theory. So like I mentioned before, there are lots of applets on if this then that. So you can go through and look through these on your own time. But in this case, we'll use Google Assistant, but you could also use an Amazon Alexa or any other device that you can think of. So for Google Assistant, we'll go ahead and select Google Assistant, and then you'll want to connect your Google account to the same account that your Google Home is on. So you go ahead and click connect. You'll want to sign in to your Google Gmail account to the same one that the Google Assistant is set up in your home. So I'll go ahead and edit this part out now, but once you connect the two just by entering your Gmail account, you'll get to this screen about choosing a trigger, and in this case we'll just say, for this example, we'll do say a simple phrase, and we'll click on that. And when you go ahead and click on that, you'll be able to set up the phrase that will trigger the feeding. You have the option of specifying it 3 different ways. For this example, we'll just say stick with feed my cat, and then you can specify the response that you want the assistant to say, in this case the Google Home, to reply back once it understands your initial phrase. So in this example, when the Google Home hears feed my cat, it'll respond back with feeding your cat now. And then we can go ahead to the trigger section, which is that section. And again, there's just as many triggers. You can go through and look at these on your own time. But for our example, we'll want to make a web request. So we'll type in web and click on the web hooks button, and then on the make a web request button. And like I mentioned previously, for the URL, you're going to want to use your duck DNS URL or whatever DNS URL that you have set up, followed by a / followed by feed button, click smart home. So that URL will trigger a feeding, and not through the website itself. It'll actually just trigger a feeding and update the time in the database itself, but it won't have to be through the website itself. And then for the method, you can just leave it as get for content type, and body, you can leave those both as blank, and then go ahead and click create action. So then you can review it, and it'll say, if you say feed my cat, then it'll make the web call. And you can click the button below if you want to receive notifications if you have the app on your phone or anywhere else, and then go ahead and click finish. And then your applet will be complete, and it will be added to your list of applets. If you need to make any changes, you can click on the gear icon if you want to change the phrases. And the check now button apparently lets you run a test of it, but I've never gotten it to work, so I would ignore the check now button and just go ahead and test it on whatever your device you're using. In my case, you can go ahead on the Google Home and say, hey Google, feed my cat, and if it responds back with feeding my cat now and makes the correct call, there it goes on mine, then it'll feed your cat. And with that, that's all it takes to set up the Google Assistant. And like I said, you can go ahead and use if this then that for many other devices and systems that they have. If you have any other useful ones that you can think of, feel free to let me know. But for now, we'll move on to the last section on setting up a motion triggered camera and live stream on the Pi. Okay, this final section will be about setting up and installing an additional camera to the Pi itself. I'll be using the official camera from the Pi Foundation, and then I will also be using an extended ribbon cable. This one is, I think, a couple feet long. And then to get the software on the Pi itself, we will be using open source Motion IO, which we'll be covering on how to set it up after this. But the first thing that we want to do is plug the ribbon cable into the camera itself, and then plug the cable into the Pi on the section marked Pi camera. And the blue tab goes toward the USB section. And your Pi case typically has a cutout section to allow the ribbon cable to go through. So just go ahead and attach the cable to both the camera and the Pi itself. And once you have that complete, go ahead and put the Pi back in and attach all the GPIO pins. I think that goes without saying that I already shut down the Pi at this point, logging in and shutting it down correctly, and then unplugging all the GPIO pins and plugging in the Pi cable at this point and hooking it up correctly. And once it's hooked up correctly, then you can put it back into its spot and plug in all the GPIO pins. Now, the cable itself, or where you position the camera, there's no right or best way on where to place it at this point. I'll present you with a few options, but and the one where I think is best, but it's really up to your imagination. You could get a longer cable and you have more flexibility or options, but what I tend to do is to run it through between the top brace and run it along the side. And I like to run it along the front of the feeder bowl itself. You can also run it along the back side of it if the cable is long enough and have it sit on top of the feeder bowl. If not, you can just kind of run it toward the middle here and kind of just situate it there. For my setup at home, having it sit in the middle and angled down allows me to capture the best motion video. But here's another potential option that I could think of. You can kind of just stick it out the front of the box and have it angled whichever way that you see fit. Or you could give it a little bit more slack and have it run along the top. You can even paint it to make it blend in a little bit more and have it held in place like that. However, this is not as important right now. We just kind of want to get it set up to make sure it's working correctly. So for now, I'll put it in this orientation. I'll just tape it along the front of the feeder bowl itself and have it a little bit of slack for it to angle down. Once we set up the motion software, you can view the camera in real time and you can adjust it to however that you see fit. And we'll do that in the further section. But for now, just make sure that the camera is plugged in correctly and that everything else is, all your other GPIO pins are set up. And once that's complete, we can turn back on the box and then complete the rest of this setup, which is installing the Motion IO software itself. So this is how I have it set up right now. Like I said, you can do it a different way. If you have a better idea, please let me know. But from here, we'll continue on and power up the Pi and move on to the software installation. And the first thing we want to do before we start with the software installation is to make sure that the camera is enabled, and go into the system processes and look on interfaces and make sure camera is enabled. If it's not, enable and then reboot the machine as necessary. And once the machine is rebooted and the camera is enabled, we can go ahead and install the Motion project software. And to do that, we'll get it from the Motion project GitHub. And to make sure you have the latest version for the Pi itself. As always, these directions are in the written direction, so you can just go ahead and copy and paste it from those. But the first thing we want to do is to download the Motion project software. And from the terminal, we'll download it to our home directory. Then after that, we will do an apt-get and install gdebi.core. And then from there, we can go ahead and proceed with the installation of Motion. And Motion itself is a very mature piece of software that has loads of configurations that can be done. In the next section, I'll touch on a few of them, the ones that I prefer, but you can go onto the Motion site itself and there are loads of documentations, and you can configure this however you see fit. And it's also worth noting that you don't need to use the official Pi camera itself. You could use any camera that can be attached to the Pi, any USB camera. But that being said, you can just continue on with the installation here. After we downloaded gdebi.core, we can go ahead and unwrap that, and once that's installed, we'll want to go ahead and make a directory for Motion in our home directory that will stick our config file in that we will end up modifying, like I mentioned previously. So we'll wait for this to go ahead and complete installing, and once that's complete, we can go ahead and make a folder with .motion so it will be hidden. And then once that's complete, we can copy the default Motion config that came with the install and put it into our newly created folder. And after that's complete, we can open the config file and we can proceed with making a few tweaks that I have found beneficial. Like I said, you can go on to the page itself and read into these more fully, and you can change them how you see fit. But these are the ones that I found pretty helpful. So we'll want to go ahead and use Nano to open up the config file. And the first configuration that I would do is once you have the config open, is scroll down and find the one config for the height and width. And the default is 320 by 240. You can go ahead and change it to 640 by 480. Like I said, you can go ahead and play around with these. At a certain point, the Pi does become under a lot of pressure if you really up these values. And then for the frame rate itself, I changed it from 2 to 20 when displaying the video. And then another config that I tweak is the post capture, which directs Motion to the number of frames after motion has been detected. If you keep it at a fairly low number, the video tends to be a little cut off the second your pet stops moving. So having to capture a few more frames after the fact makes the video a little bit more smooth. And then the max movie time, I just stick it to 2 minutes, just so if there is something in the peripheral, like a tree or something in the background that's constantly moving, like a fan, you don't want a video running for hours and hours. So I just set the max time to 2 minutes. Again, you can tweak that as you see fit. And the next one we want to make sure that we change is the target directory for the video location themselves. We will move this to the var www /feeder/fleeter, and this will tie in directly with the website itself. The website is designed and developed at this point to work directly with motion and not really any other kind of video capture system. So we want to update the path to where the videos are stored, and since they'll be stored at this feeder location, then they'll be available on the website to be viewed remotely or locally. So we'll go ahead and look for the target directory. If it is commented out, you can uncomment it and then type in this path. And then the last three settings that we want to change are related to the stream and the admin site that comes along with the motion stream. So as you stream the live video, in addition to motion video, you can look at the live video. You can set the quality of that. The default's 50. I bump it up to 80. And you can also change the rate at which the frames are shown on the stream itself. The default is 1. I just bump it up to 15. And then the last one is the local host is currently set to on, which means you can only view the live stream on this Pi itself. You can change that to off so you can view it on some other machines. And once these changes are made, go ahead and save the file. And we can move on to the next step. Is we have to tweak a few more other things just to make sure the Pi works correctly in conjunction with the camera. So the first thing we want to do is to open up the sudo nano and then etc module section, and there's one other thing in there, and you want to add the line BCM 2835-4L2, and this is for the Pi camera that I'm using specifically. And you want to make sure that you copy this value from the written directions. Make sure you don't mistype it, or otherwise it will not work. So save that file, and then you can open up another file with nano at the etc/rc.local, and within there, right above the last line, which has exit 0, and we'll want to add the line which will basically start the motion service at startup when the Pi reboots or starts up, and it will reference the config file in our home directory that we just tweaked above. So go ahead and type that line in as well. And save and exit that file. And then the last thing we can tweak is to modify the boot /config.txt, and this basically turns off the LED light on the camera. Anytime the default Pi camera is in use, the red LED light stays on, and it's kind of annoying to me. So if you want to turn that off, you can open up the config.txt file, go all the way down to the bottom, and then type in disable_camera_LED camera_LED, and then put that equal to 1. And then after that's done, we can go ahead and save that file and reboot the machine before moving on with the next steps to verify everything's working correctly. And once the machine's done rebooting, we can go locally onto our browser on the Pi with 127.0.0.1, and you'll notice now that the website kind of shifted around a little. The schedule time's pushed to the bottom, and now there's a section on to the right for latest videos and size, and then there's also a button that says live video. So to verify that the motion service is running, we can do 127.0.0.1 and then pound 8080, and that'll take you to the live stream. As you can see, the camera's sitting on my desk. And then from the 8080, there's also a bunch of configs that we manually changed before. There also is the ability through the motion admin console to change here. And port 8080 takes you to this admin console, which also has an in-display of a live feed. But if you go to port 8081, that'll take you to just a picture of the live feed itself. And it is this link this 8081 port, which will be used on the live video button itself. So we can go back to the main web page now, and I'll go ahead and just move my hand around the camera, which is just sitting on my desk, to trigger a video. And then if I restart the admin page, you'll see that there is a video there now. So if I click on the video, it'll have the time, and if you play the video, depending on if your browser, there might be a play button in the middle, otherwise you can just click on the bottom and you'll see there's just a picture of me waving my hand. So we have verified that everything's working as expected now. When we move our hand, the motion service triggered, saw motion, and captured a small video, and that video was saved to the var feeder folder, and now it's displayed on the website. And if we go into that folder, you'll see that there is a video there now. And the length of time and the number of videos that will be displayed are all configurable, and we can cover that in the next section. So as I mentioned, there are a few configs that need to be made, and if you notice also when you click on the live feed button, you will see that the link is not working. It'll be referencing a your remote address .8081, and that is because the config needs to be tweaked to whatever your DNS settings are to be able to access the live feed. And the way that this can be changed is, if you remember in the previous section, there is an app.config file under var feeder. So if you open that, there are some configs that are related to the camera that can be changed. In particular, for the live video button to work, you'll want to go ahead and change this motion camera site address, and you'll want to change that to whatever your duck DNS or whatever DNS that you have set up. Just because I'm on the local machine right now, I'll just go ahead and change this to the local IP address, but you'll want to change this to whatever you have configured. And once that is saved, like I mentioned previously, you want to go ahead and restart Apache for everything to take effect. And once that is done, we can restart the browser and click on the live feed button. And if you have it configured correctly, when you click on live video, you should be able to see the current live stream from the camera itself. And there it goes. So in addition to viewing the live stream at any time, it will also trigger when it detects motion. And from the live stream, you can, like I mentioned when we were setting this up, you can change the camera to however you see fit. Now it is worth repeating again that I set the config to the local IP address just for this demonstration, but you'll want to change it to your duck DNS address or whatever address you configured. In addition, with this current example, this would only work on the local network. If you want to view the live stream on the website outside of your home network, you're going to have to forward port 8081 to the local IP address of the Pi. This is done exactly how we forwarded port 80 previously in the tutorial, so if you need a refresher, go back to that part and take a look at that again. So on your router, you'll end up with another row in addition to port 80 in your port forwarding section. So you'll have a total of 2 rows, one for port 80 and one for port 8081, pointing back to the Pi. And then you'd want to go ahead and reboot your router as necessary. Back to the config section itself, you can tweak a few other things, such as how many videos you want displayed on the website itself. Currently it's set to display 100, so if you have a lot of movement from your pets, that could be quite annoying, so you can tweak that. You can also tweak the number of days of videos to keep. So right now it's set to 1. So the service that runs in the background, the time service, every time that it detects videos older than 1 day, it'll delete them. So your SD card won't run out. So after a day, this video that I just shot will be deleted. If you want the videos to stay around longer, you can change the number of days of videos to keep from 1. You can change it to a higher number. And then also, like I mentioned before, The number of videos to display on the website is set to 100. You can lower that or raise that as you see fit. And that's pretty much all there is to setting up the camera. Like I said in the previous final thoughts, if you have any questions about setting up the camera, feel free to let me know. And if you have any other ideas to enhance or modify the feeder or camera, also please let me know. I'm welcome to any ideas or suggestions. But for that, that's all there is for now. So I hope you enjoy your pet feeder and talk to you soon. Bye.